Yes, good morning, madam.
Sir,
Am I
start the
audible?
class, sir.
Very
Good
yes, madam.
morning.
Very
Yes,
good
sir.
morning. Okay, okay.
Yes, sir.
Okay, good morning, students. I should we start the class of today's session. So, when the MCQ related to failure theories, as well as we will do regarding shear force and bending moment diagram. I will try to cover maximum topic in this particular class. Okay, okay. So, if we move on to the part of failure theories. Is the screen is visible?
Yes, sir.
Yes, sir. Okay. So last class we discussed regarding the fracture of metals or any material subjected to loads. So we can expect yielding and fracture type of failure, particular fracture type of deformations, as well as the different materials are brittle and ductile. So these are the different theories we already discussed regarding this maximum principal stress related to Rankine's, principal strain, Saint-Venant's, and shear stress, Coulomb, Tresca, Guest, as well as shear strain is Haig and Beltrame's theories, and distortion theory is Van Massus and Henke. Right. So these are the very important thing. Mainly, what is the main aspect you have to remember while we are concentrate on failure theories are the conditions. The conditions plays a major role when you are solving numericals or a few questions you may expect related to theoretical aspects. In theoretical aspects, especially the yield locus. The yield locus for principal stress is rectangle, as well as the yield locus for principal strain is, what is the yield locus for principal strain theory? Yesterday class we discussed what is the yield locus? Parallelogram. So very important thing, right? Conditions. See, these conditions are very important. In previous, the condition is the major principal stress if exceeds sigma y, the failure of principal stress will comes into picture, right? And also this particular condition is that is major principal axis sigma 1 minus Poisson's ratio mu times of sigma 2. We should be less than sigma y, the kinds of failure theory we may see. Okay. Next, maximum shear stress theory. This is because of if shear type of force will exceed in material will cause shear failure. So this is mainly the condition occurs there. Sigma 1 minus sigma 2 less than sigma y. This is very important here. And the yield locus. Yield locus for shear stress is hexagon. And the next one is maximum strain energy theory. This is whatever the energy stored inside the material. When we are applying the external forces, the utilization of energy comes into picture, and the main conditions is very important one. It is in the form of a minus b whole square, but the mu term will come, and it's greater than sigma y square or sigma t square, because generally why I am using here t, because generally these tests are conducted under tension. Hence here sigma t, sigma y both are same. So don't confuse with the notations. So if I want, if you take sigma t square in denominator, this kinds of equation will arrive. This equation is also very important. In MCQ question, you may expect the direct things with respect to equations or in the form of match the following. So, and the yield locus for maximum strain energy theory is ellipse. And the last one is distortion energy theory. So this is also a part of total strain energy one. And the condition is very important. Here, there is no 2 mu and mu. Here, instead you eliminate whatever 2 mu, you are getting only sigma 1, sigma 2, which is equal to yield. So the yield occurs mainly an ellipse. What are the comparison of different energy theory failures? This is the comparison, mainly because of yield locus. Yield locus for maximum principal stress theory, we just observe here, it's a rectangle one. Yield locus for maximum principal strain theory, you just observe this point, as well as this point, and this point, and this point. So parallelogram, that is maximum strain, principal strain energy theory. And you may observe that there's an one more, that is hexagon. 1, 2, 3, 4, 5, 6 hexagon. For hexagon, maximum shear stress theory. This is for hexagon, and you see the ellipse. It's a circle like a egg shape. It's an ellipse. So this is for maximum distortion energy theory. You may expect MCQ related to, they may give the different locus pictures, figures, and you have to identify. They will give code A, B, C, D, and they will mention like different theories in terms of name, or they may give researcher's name. Please tell me what who's the researcher find out maximum principal stress theory. So maximum principal stress theory is also called what? You know,
Rankine's theory.
yes, very good. Rankine's theory.
Rankines.
Very good. What is maximum principal strain theory?
Saint Venant.
Yes, Saint Venant's. What is maximum distortion energy theory?
Van and Messis.
Mrs.
Van Messis?
Hanky
Yes,
theory.
here is there, Henke. So they may give any one of the researcher name, or they may give both the researchers name. So you have to be careful. Okay, Van Messis or Henke's. What is maximum shear stress theory? Who gave the shear stress theory?
Column Tezos on guest.
Yarappa?
Columns.
Coulomb. Only Coulomb? Tresca. Right?
Tresca and guest.
Yes. Right? See, strain energy, what we discussed regarding. See, Coulomb, Tresca, and guest. So they may give any one of the researcher mark, may give both the researchers' name to confuse you people. Okay, please be careful. But generally, Tresca is very, very important. Tresca, generally, they will ask when mass is Tresca and all. So if you are talking about energy theorems mainly because of when mass is Hensky. Okay, if you are talking about shear stress, Tresca plays a major thing. And if we talking about maximum principal stress theory, Rankine's plays a major role. Like that, these are the very, very important things. Okay, so any doubts? Any doubts?
Oh, sir.
Shall we move on to MCQ questions? ಕೇಳಿಸ್ತಾ ಇದೆಯಾ ಮಾತಾಡ್ತಾ ಇರೋದು?
Yes, sir.
Okay. So these are the which are different theories suitable for brittle and ductile material. For brittle type of material, generally which theory? Rankine's theory. See, they may give researcher's name, or you must familiar with these notations. It's very easy to identify. So for brittle material, generally Rankine's theory or principal stress theory is valid. Okay. For generally for ductile material, distortion energy theory is very good. In some cases, in MCQ questions, what they happens, they won't give. ಅವ್ರು ಏನ್ ಮಾಡ್ತಾರೆ, ಡಿಸ್ಟಾರ್ಷನ್ ಎನರ್ಜಿ ಆಪ್ಷನಲ್ ಇರೋದಕ್ಕೆ ಇಲ್ಲ, ಏನ್ ಮಾಡ್ಬಿಡ್ತಾರೆ, ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಕೊಟ್ಟಿರ್ತಾರೆ. So on that cases, in some cases, shear stress theory is preferably good for ductile type of materials. Any doubts? For ductile materials, both distortion as well as maximum shear stress theory is valid. For brittle materials, Rankine's theory or maximum principal stress theory is valid. Clear? Okay, move on to the MCQ question. So these are all very, very simple MCQ depending on the failure theories. Please identify the most appropriate theory for ductile materials. Now only I have just discussed it. What is the answer?
Distortion energy theory.
The most appropriate theory for ductile materials?
Distortion theory.
Distortion
energy.
Option C.
If distortion energy, they may give
Maximum shear stress.
yes, maximum shear stress. Okay, what is the maximum principal stress theory is normally used for?
Ductile material.
Ductile materials. It's very simple. Ductile materials, this is right. Ductile materials. See, you just observe. The most appropriate theory for ductile materials is distortion and shear stress. Here, what is asked? The maximum.
Brittle materials.
Yes, brittle materials. Be careful. Maximum principal stress, or some other words, Rankine's theory. For which type of material?
Brittle
materials. not ductile one. We must be careful while you are identifying the answers. These questions are looking it's very simple, but if you make a mistake in 1 second by without thinking, it may become wrong. You are losing 0.5 marks. Clear? So any doubts? Any doubts?
No, sir.
Okay. Yes, we are moving to third question. Maximum shear stress theory does not hold good if condition of stress is. Yes. When the maximum shear stress does not hold good. So we are talking about shear stress. What is the condition for shear stress? What is the condition for shear stress? You must be
Sigma 1
generally,
Sigma 1 minus sigma 2 is lesser than sigma 1.
yes, generally what happens, generally these shear stress theories are not good for triaxial test, triaxial state of whatever loads. But here in option, this is biaxial, it's okay. It's having good condition. This is also uniaxial, this is okay. The options are triaxial. There are two options, B and C. Here, which is not having a good condition. Generally, the greater one is right. This holds, but this will not having good conditions. So the answer is B. Okay. Please keep in your mind when you are solving shear stress theories is not good with triaxial state. In triaxial state, especially if they all are equal, no meaning. If all direction stresses are equal, there is no meaning at all. Hence, shear stress theory does not holds good if condition of stress is sigma 1 equals sigma 2 equals sigma 3, especially in triaxial state. Especially in triaxial state. Clear? This is the wrong one. This is the wrong, which means it's not holds good. It's a not holds good. Okay, remaining all will fit to this particular theory. Remaining three options are will fit to maximum shear stress theory. Triaxial load with respect to all stresses are equal will not holds the condition of maximum shear stress, because if you are taking all stresses are equal, are you getting maximum value? Please think. If all stresses are equal, then obviously shear stress in all directions are equal. Then if the greater one, sigma 1 greater than sigma 2 greater than sigma 3, then you may expect a good condition, right? Hence, we have to pick the second option. So any doubts?
No, sir.
Any
No, sir.
doubts? Okay. We move on to fourth question. Brittle material subjected to pure shear fails. Yes, please guess when it fails. A brittle material, I am talking about brittle material subjected to pure shear state of stress, when it fails. You know that. Yes, please try to guess the answers.
Options B.
Option B. Any other answers? Any other answers? Please, participate. You are around 30 students. I am expecting all students to participate. ನೀವು ಇಲ್ಲಿ ಟ್ರೈ ಮಾಡಿದ್ರೆ ತಪ್ಪಾದ್ರೂ ಪರವಾಗಿಲ್ಲ, ನಾನು ಹೇಳ್ತೀನಿ, ನೀವು ಎಕ್ಸಾಮ್ ನಲ್ಲಿ ತಪ್ಪು ಮಾಡಬಾರ್ದು ಅಷ್ಟೇ. Yes, any other answers? When brittle material subjected to fracture. What is meant by fracture? What is meant by pure shear? Yes, tell me what is meant by pure shear? I have explained what is meant by pure shear.
Bending.
90 degree.
It's having normal stress and tension.
Yes, see, generally, see, I am talking about brittle material. What is the nature of stress ranker for brittle material? You just try to capture the thing like this, right? There is no yield. There is no yield. You are getting which point? Ultimate point in brittle materials, right? Ultimate point. So you just observe the answers. You just observe the answers, which is having ultimate having only C and D. C and D, right? Ultimate option you are having only C and D. See, yield ಬರಲ್ಲ brittle material ನಾಗ yield ಬರಲ್ಲ. Brittle material ನಾಗೆ ನಿಮಗೆ ಬರೋದೇ ultimate. ಸರಿ ಅಲ್ವಾ? So ಏನಾಗುತ್ತದೆ? So ultimate option D ಎರಡರಲ್ಲಿ ಒಂದು. ಇವಾಗ ಬನ್ನಿ brittle material ನಾನು ನಿಮಗೆ ಫಸ್ಟ್ ಸ್ಲೈಡ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದೆ. Which type of failure you may expect in brittle material?
Yield.
Yielding a fracture.
Fracture.
Yes. Be careful. ಯಾಕೆಂದ್ರೆ ಫಸ್ಟ್ ಸ್ಲೈಡ್ ನಲ್ಲಿ ನಿಮ್ಗೆ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದೀನಿ. ಬ್ರಿಟಲ್ ಇದ್ರೆ that is fracture. That is yield. So here which option is right?
Option C.
Option C.
Yes. Thing very important. See, firstly identify the type of failure, that is ultimate one. There is no yield point, there is no yield in brittle type of fracture, hence first two are eliminated, only C and D options are left. And also we must know that for brittle there's a fracture, hence a brittle material subjected to pure shear fails by fracture under tau max equal sigma ut by 2. Any doubts?
No,
Any
sir.
doubts?
No, sir.
No,
Clear?
sir.
Okay. See, ನಿಮಗೆ ಗೊತ್ತಾಗ್ಲಿಲ್ಲ ಅಂದ್ರೆ ಕೇಳಬೇಕಪ್ಪ. Okay, next. Safe area of stress diagram for maximum energy of distortion theory is represented by. See, safe area diagram ಅಂದ್ರೆ ಈಗ ನೀವು ಅಲ್ಲೊಂದು ಫಿಗರ್ ತೋರಿಸಿದ್ನಲ್ಲ, ನಿಮ್ಗೆ ಇಲ್ಲಿ ಸಿಗ್ಮಾ y ಸಿಗ್ಮಾ x ಅಂತ ಬರೆದ್ಬಿಟ್ಟು ಎಲಿಪ್ಸ್ ನ ಮಾಡಿದ್ರು, ಸರಿನಾ? ಸೊ ಈ ಎಲಿಪ್ಸ್, ದಿಸ್ ಇಸ್ ದ ಸೇಫ್ ಏರಿಯಾ, ಯಾವ ಒಂದು ಪಾಯಿಂಟ್ ಗೆ ಹೋಲ್ಸ್ ಗುಡ್ ಆಗುತ್ತೆ ಅಂತ. ಸೊ ಇದು ಇಸ್ ಎ ಮೆಮೊರಿ ಬೇಸ್ಡ್ ಕ್ವಶನ್, ಸೊ ಡೋಂಟ್ ಟ್ರೈ ಟು ಸರ್ಚ್ ವಾಟ್ ಆರ್ ದ ನ್ಯೂಮರಿಕಲ್ಸ್ ರಿಲೇಟೆಡ್ ಆಲ್ ದೋಸ್ ಥಿಂಗ್ಸ್. ಸೊ ಪ್ಲೀಸ್ be with in your mind. The answer is, this is generally with respect to the maximum portion will share by maximum major axis at 2 root 2 sigma yt, 2 root 2 sigma yt. This is the answer. So general, it's a memory based question. So generally they will ask safe area of stress diagram for maximum energy of distortion theory represented by, it's an ellipse, you know that. So ellipse ಅಂದ ತಕ್ಷಣ ನಿಮ್ಗೆ ಇವೆರಡು, ನಿಮ್ಗೆ ಇದು ಬಂದು ಮ್ಯಾಕ್ಸಿಮಮ್ ಸ್ಟ್ರೆಸ್ ಎನರ್ಜಿ ಅಂದ ತಕ್ಷಣ ನಿಮ್ಗೆ ಏನು ಅದ್ರದ್ದು yield locus ಏನು? The yield locus for maximum, the yield locus for maximum energy is ellipse, you know that.
Ellipse.
So the square option is eliminated, the rectangle option is eliminated. The remaining things, see, for maximum energy distortion 2 root 2, for another one strain energy the ellipse is 5 root 2. Clear? Any doubts? There are two energy things in an ellipse. One is for distortion energy and another one is for strain energy. Clear? Any doubts? ಹೇಗೆ ಸರ್ಚ್ ಮಾಡೋದು ಗೊತ್ತಾಯ್ತಾ? ಮ್ಯಾಕ್ಸಿಮಮ್ ಎನರ್ಜಿ ಥಿಯರಿ ಅಂತ ಬಂದ ತಕ್ಷಣ yield locus ಏನು ಅಂತ ಎಲಿಪ್ಸ್, ಇಲ್ಲಿ ಆಪ್ಷನ್ ನೋಡ್ಬೇಕು, ಸ್ಕ್ವೇರ್ ರೆಕ್ಟಾಂಗಲ್ ಎಲಿಮಿನೇಟ್ ಆಗೋಗುತ್ತೆ. ಸೊ ಉಳಿಯೋದು ಯಾವುದು? ಇವೆರಡನಾಗ ಡಿಸ್ಟಾರ್ಷನ್ ಎನರ್ಜಿಗೆ 2 root 2, ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿಗೆ 5 root 2. ಎನಿ ಡೌಟ್ಸ್? ಕ್ಲಿಯರ್? ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? ಏನಾದ್ರು ಪ್ರಾಬ್ಲಮ್ ಇದೆಯಾ? ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಇದೆಯಾ? ಕ್ಲಾಸ್ ಇದೆಯಾ ಸ್ಟೂಡೆಂಟ್ಸ್?
No, sir.
Okay. Yes. See the next question. Yes. What is the relationship between maximum utilizable values obtained by tension test and pure shear test for maximum shear stress theory? Yes. What is the relationship between maximum utilizable value for tension and pure shear test? Yes. Any guesses? Any guesses?
Yes, sir.
Yes. ಏನಪ್ಪ?
Please, sir.
ಯಾರು ಹೇಳಿದ್ರಿ? C. Any other answers? Yes, the answer is C. C, the relationship between maximum utilizable values obtained by, see, you go to any test, it may be tension test, it may be pure shear test. What happens generally, we will take yt sigma y by 2. If you observe the equation in both the theories, whatever shear and under tension, we will take sigma y by 2. What is sigma y by 2? Sigma y by 2 is nothing but 0.5 times of y. So this is right answer. Generally they will ask in all tests, generally we will take 0.5 times of yield, 0.5 times of yield. So this is the relation, that is sigma sy equal 0.5 times of sigma yt. This is also direct question. This is all memory based questions. If they ask these questions, don't think too much. You keep in your mind that if any tension and shear, those type of, generally the stresses will be 0.5 Energy distortion theory, you just of sigma y. This type of is a memory based question. Generally, they will say 1 or 2 memory based question in this particular part. Clear? Shall I move on to next question?
Yes, sir.
Follow ಮಾಡ್ತಾ ಇದ್ದೀರಾ?
Sir.
Okay.
Yes, sir.
Yes, this is very, very important. See, under biaxial stress condition, sigma 1 equals sigma 2. Mu, that is Poisson's ratio, is given as 0.25. The maximum values of sigma 1 and sigma 2 applying maximum energy distortion theory is. See, what is the equation for maximum energy distortion theory?
Sigma 1
Equation
square plus
ಏನಪ್ಪಾ?
sigma 2
Maximum
square
energy
minus sigma 1 by sigma 1 sigma 2 is equal to sigma y square.
Yes, sigma 1 square plus sigma 2 square minus
2 ಅಲ್ಲ ಸರ್ ಅದು sigma 1 into sigma 2.
sigma 1 square plus sigma 2 square minus sigma 1 sigma 2, which is equal to
Y square.
sigma y square. This is the maximum energy distortion. Here, what is the condition given? Sigma 1 equal sigma 2. What happens? Sigma 1 square, sigma 2 is sigma 1 once again. Sigma 1 square minus sigma 1 into sigma 1, sigma 1 square, sigma y square. What happens? 2 sigma 1 square minus sigma 1 square will become sigma 1 square, sigma y square. Square square get cancelled. Sigma 1 equals,
Sigma y.
which is the option?
C.
Which is the option?
C.
C.
See, sigma y, sigma 1 equals sigma y, which is the answer?
C.
Sigma y under tension. So the
C.
answer is C. C. See, these are very, very simple questions and also little bit complicated, moderate type of questions. You must remember the distortion energy theorem and you have to apply the condition, then you are getting the answers. So likewise, you may for rank expect for generally they will ask for energy distortion. Okay, so simple problems. This is very simple. Given a condition, state of stress, both are equals. You are substituting the equal state of stress.
Your voice is breaking, sir.
Voice
Sir,
is breaking.
Fully break ಆಗ್ತದೆ ಸರ್.
Voice full break ಆಗ್ತದೆ.
ಹೌದಾ? Okay, wait. Okay, are you getting the same disturbance?
No, sir.
Okay. Yes, next question. This is very, very simple question. Match the following. Yes, please guess. Please guess. Guess, Modi. What is guess theory? What is hike theory? What is Venn-Messes and Henke? What is Morse? Which one is right? Which code is right? Yes, any answers? Please guess.
Sir, D2.
Okay. Others?
Then
C.
Yes. The option is C. The option is C. C. Guess theory. What is guess theory? Guess theory is option 2. Sigma 1 minus sigma 2 equals YT. This is 1. Next, Higgs theory. What is Higgs theory? You have to remember this equation. I told that you can easily judgeable Higgs theory. That is sigma 1 square plus sigma 2 square minus 2 times of sigma 1 sigma 2 equals Y square. What is Van Messes theory? What is Van Messes? Here there is no 2 in Van Messes, right? So this is third one, Van Messes. So here the Mohr's theory. The Mohr's theory is sigma 1 minus sigma 2 equals sigma y. Sigma 1 minus sigma equals sigma y. So this is the fourth one. So be careful when you are judging these type of codes. So here options are 2, 4, 5, 3. 2, 4, 5, 3. So answer is code is C. So any doubts? Any doubts? It's a direct question, but you must be remember the codes, equational codes. That's a very, very important. Equations. What are the principal stress equations? You have to remember those things. Next question. Please guess. It's very simple. Ninth one. Which theory of failure will you use for aluminium? Aluminium is which type of material? Please guess the first one. Aluminium comes under which type of material?
Ductile.
Ductile material.
Okay, then which is the theory applicable for ductile?
Maximum principal
Maximum
strain.
strain energy theory.
ಯಾವ theory?
D, sir, D.
ಈಗಿನೂ discuss
Sir,
ಮಾಡಿದೀನಿ.
maximum shear stress.
Yes.
Principal strain.
Yes, because energy is not given, hence it is B. Right? So aluminium is ductile material. For ductile material, energy theory or shear stress theory. So here energy theory is not given. That is especially which distortion energy. This is very important. Distortion energy. So here distortion energy is not given. Hence the option is shear. Right? Have you got? So in some cases, I may give instead of aluminium, they may give instead of aluminium, they may give like glass. In this case,
It's a brittle in nature.
yes. Which
Option
theory?
Principal
A.
stress.
Option A. Instead of aluminium, they may give mild steel, MS.
It is also ductile.
Ductile. So what is the answer?
Principal stress.
Option D.
Yes, shear stress, not principal stress.
Shear stress.
Then ductile, right? Don't confuse. Confuse ಮಾಡ್ಕೋಬೇಡ್ರಿ.
Yes, sir.
Okay, clear. This concept is very simple. Okay. ಇಷ್ಟೇ ಕೇಳಕ್ಕಾಗದೆ ಇದರಲ್ಲಿ ಬೇರೆ ಏನು ಕೇಳಕ್ಕಾಗಲ್ಲ. ಈ ಆಪ್ಷನ್ಸ್ ಪ್ಲೀಸ್ ಗೆಸ್. What is the code? Wait.
A5.
A5. Okay. Now please guess now. Afterwards I will give the code. Yes. Others. Other answers.
B3.
B3.
A maximum principal stress theory. Maximum principal stress theory is given by Rankine. Okay. Next.
C2.
Maximum shear stress given by
Tresca.
Tresca. Okay.
Tresca
Okay. ನಿಮಗೆ ತುಂಬಾ ಈಸಿ ಆಗುತ್ತೆ. ಯಾವುದು ಫಸ್ಟ್ ಪ್ರಿನ್ಸಿಪಲ್ ಸ್ಟ್ರೆಸ್ ಈಸಿ ಆಗುತ್ತೆ. ರ್ಯಾಂಕ್ ಕೈನ್ಸ್ ಐಡೆಂಟಿಫೈ ಮಾಡಿ. ನೆಕ್ಸ್ಟ್ ಪ್ರಿನ್ಸಿಪಲ್ ಸ್ಟ್ರೈನ್ ಈಸಿ ಆಗುತ್ತೆ. ಯಾರು ಸ್ಟ್ರೈನ್ ಕೊಟ್ಟಿದ್ದು? Yes, 20 minutes. So 3. Next distortion energy ನಿಮ್ಗೆ ಈಸಿ. Distortion energy ಯಾರು ಕೊಟ್ಟಿದ್ದು?
One message.
One messes or Beltrami and Haig. See, please be careful when you are guessing the answer. Yes. Now, what is the code? What is the code? A,
A,
B, C, D. See, you have to
A
see
five.
one A5. There are two options, A and B, A or B. So you go to C3. C3 is C1, right? C1. C1 is having which one option? This one.
Then yes.
A. Then
C2.
you may guess easy. A is right? Next is Tresca, right? Tresca, right? Next Saint Venant's, right? Here one is right. Okay. Distortion energy is one masses. Strain energy is Beltrami and Haig.
Right.
Strain energy. So instead of distortion energy, if they give strain energy, then you have to go for Beltrami and Haig. So any doubts? So here we saw regarding principle. That is any doubts in failure theories? Any doubts in failure theories?
No, sir.
Any doubts?
No, sir.
See, only these kinds of things you may expect, because see, if you observe each and every question, the possibility. So there are only 5 theories. I have already told that they are having 5 theories, and in these 5 theories, the main thing, what the thing is, we can expect the questions definitely. But also you may expect like yield locus, right? In yield locus also, so we solved so many things like the condition oriented problems we solved. Okay, so and this one is best suitable for brittle and ductile materials. In this part, they may give like you may expect few of the questions like material. Give few examples for brittle materials and give few examples for ductile materials. Yes, what are the examples for brittle materials?
Concrete.
Glass, concrete, ductile, MS, aluminium. Okay, see, there are so many things. So they may give specific material oriented questions, specific material oriented questions and all. Okay, now we will finish this part, that is failure theories. If you're having any doubts, please ask me. I will clarify your doubts. Next, after this particular thing, we will move on to the next topic, that is shear force and bending moments. So any doubts? Any doubts?
No, sir.
Others?
No, sir.
Others? If you are having doubts, I will move to the next topic. If you are having doubt, I will take your doubts and I will clarify doubt. Okay. Now the thing, what all are we just discussed? The first we discussed regarding basics related to stresses, material properties, and also we discussed regarding elastic constants, stress strain curves. Okay, next what we discussed, thermal stresses. Thermal stresses. Next what we discussed, two-dimensional stress system. That is your principal stresses and strains. And also we discussed failure theories.
More, sir.
So the major 4 topics we covered. Any doubts? Any doubts? Majorly we covered 4 topics, very, very important topics. Any doubts? Shall I move on to the next topic?
Yes, sir.
Okay. The next topic is shear force and bending moment diagrams. See, you are having more or less the new core topics in coming sessions. The core topics are especially influence line diagrams, as well as determining the shear forces, determining the final end moments using moment area method, that is using conjugate beam method, whatever in determinate structures or indeterminate structures. In indeterminate structures, we are having the moment distribution method. and the slope deflection method, Cannings's method. There are several methods. Whatever the method to determine the final moments, we must know the concepts of shear force and bending moment diagram. So these are very, very essential in structural engineering to know the behavior of structural members when it is subjected to loads. What happens if any kind of structure, the structure may be horizontal structure, the structure may be vertical structure, the structure may be inclined one. So if they are subjected to loads, what happens? They behaves in different manner depending on few things like mechanical properties and some other behavior under different kinds of loadings and all. So that's why generally we must know the, if I am applying the, if you consider any of the member, if you are applying different types of loads, what are the significant changes occurring inside the material? That is the inside, what is undergoing inside the material. So generally what happens, generally there are two things. One is in terms of external reactions and one is in terms of external reaction, that is supports, that we call as supports. Another thing, there are internal behavioral changes because of these external forces, These are the things are nothing but shear forces and bending moments. Sir, the inherent changes, what is happening inside the material because of external force application. The nature we are going to study with the help of shear force and bending moments diagrams. So now I will take shear force. What exactly the meaning of shear force? So any definitions from your end? What is meant by shear force? Try to attempt. If it is right or wrong, no matters. What is meant by shear force? The name itself indicates a force. Shear. What is meant by shear? The force acting on the surface. The force acting on the surface is called shear force. Right? So now the thing is, we will go by one on basics. Shear force and bending moment diagram. This is very, very important topic. So well before knowing this particular topic, we must know what is meant by beam. Yes, please explain what is meant by beam. Any answers? Beam. Just try to give some of the things. What is meant by beam?
It is an horizontal structure which transfer the loads to columns.
Yes, very good. It's a horizontal structural member. It's a one-dimensional horizontal structural member. It's very, very important. Beam is a one-dimensional structural member. One-dimensional horizontal structural member means why it is one-dimensional? What is the reason I called it as one-dimensional structural member? Any answers? Why it is called one dimension? What is meant by one dimension? See, observe how the beam. This is a one-dimensional, which means the beam is having larger length compared to depth and breadth. See, if it is a beam, what happens? This surface is called breadth. Breadth and depth, that's the area, cross-sectional area, B into D, is small compared to length. Hence, we termed it as one-dimensional structural member. The one-dimensional structural member means the length is large compared to breadth and depth. Beam is an one-dimensional horizontal structural member, and it's having ability to take loads, transverse loads. Transverse loads means what is meant by transverse load? Transverse means perpendicular. See, this is the beam. This beam is taking load in which direction? Perpendicular direction. So the beam means The beam is an horizontal one-dimensional structural member. It is having ability to take transverse load. Usually there's a long, straight and prismatic. Long, straight and prismatic means it's a straight members. Prismatic means the flexural rigidity. If you see the construction, reality of construction, all are prismatic, means the flexural rigidity is same throughout the length. That is EI. In practical situation, the EI value is same. That's why we termed it as prismatic. Okay. And also now, once you know the what is meant by beam, next, what are different types of supports? You have studied already. What is meant by supports? What are different types of supports?
Simply
Fixed
supported,
supports.
Simply supported.
overhanging, cantilever.
Can
Yes, that's right.
point load. Uniformly
Yes,
distributed.
yes. See, this is the horizontal member. What happens? This horizontal member must be rest on few things. That is supports. So generally we are having, this is which kind of support?
Simple support.
Simple
Simple
support. Now I'll provide one more support. This is which kind of support?
Cantilever.
Cantilever.
That is fixed support. See, you are getting confusion. Yes, I got. Now if you see, this is one, this is separate. Now this is simple support. This is fixed support. Next, what are the other supports?
Hinge.
This is hinge. This
Roller.
is which kind of support?
Roller.
Roller. Sometimes.
Mute ಮಾಡಿ.
ಯಾರಪ್ಪ ಅದು?
ಸರ್ ಮ್ಯೂಟ್ ಮಾಡಿ.
ಎಸ್ ಮಾಡಿದ್ದೀನಪ್ಪ, ಕೇಳಿಸ್ತಾ ಇದೆಯಾಗ? ಸರಿ ಆಯ್ತಾ? ಐ ಥಿಂಕ್ ನಾನು ಇವಾಗ ಮ್ಯೂಟ್ ಮಾಡಿದೆ, ಯಾರೋ ಓಪನ್ ಮಾಡ್ಕೊಂಡಿದ್ರು. ಓಕೆ, now is it okay? I think now there is no disturbance. Clear?
Yes, sir.
See, hinge. This is hinge, this is roller, and this is fixed, and this is simple support. See, the beam is an horizontal member. The beam is an horizontal member. This horizontal member is rest on this, whatever I have mentioned here, within this supports. Okay, now I will explain how the simple beam behaves, how the hinge support behaves, how the roller will behave. See, please keep in your mind while writing reactions or kinematic indeterminacy, static indeterminacy, this basics plays a major role. That's why. Okay, now tell me, in any planar structure, two-dimensional structure, what are the possible kinds of displacements? What are the possible kinds of displacements? So the planar structure may be displaced in x direction, displaced in y direction, or it may displace due to rotation, moment. So in any structure, the possible way of displacements are fx, fy, and m. Fx, fy, and m. So if you consider a beam, say I am providing at both ends simple support, So at each joint, the possible deformations are 3. What are those? Fx, fy, and m. These kind of simple beams will resist vertical reaction. Here, the vertical reaction, it will resist vertical reaction, but it cannot resist the rotation as well as horizontal displacement. It will not resist horizontal moment as well as rotations. Hence, These kinds of beams are generally preferred. It's not preferred for more and more in like this kind of simple support where you can see ಎಲ್ಲಿ ಅಂದ್ರೆ ಈಗ ನಿಮ್ಗೆ ಏನಾಗುತ್ತೆ ಒಂದು ಸಣ್ಣದಾಗಿ ಒಂದು ಏನಾಗುತ್ತೆ ನಿಮ್ಮ ಮನೆ ಹತ್ರ ಚರಂಡಿ ಇರುತ್ತೆ, ಆ ಚರಂಡಿ ದಾಟಬೇಕು, ಆ ಚರಂಡಿ ದಾಟೋದಕ್ಕೆ ನಿಮ್ಗೊಂದು ಕಲ್ಲು ಹಾಕಿರ್ತಾರೆ. ಸೊ ದಟ್ ವಾಟ್ ಎವರ್ ದ ಸ್ಟೋನ್ ಈಸ್ ರೆಸ್ಟ್ ಆನ್ freely on the concrete slab, right? So ಇದನ್ನ ನೀವು ಎತ್ತು ಬಿಡಬಹುದು ಈಸಿಯಾಗಿ. You can lift this. Why you can lift this? It will resist only the thing is vertical gravity loads. It cannot resist other type. You can easily push this one. ನೀವು ತಳ್ಳಿಬಿಡಬಹುದು ಮುಂದಕ್ಕೆ. Why you can push this one? Because it will allow the horizontal one. You can ನೀವು ಎತ್ತಬಹುದು, ಮೇಲಕ್ಕೆ ಎತ್ಬಿಟ್ಟು ದಬಾಕ್ಸ್ಬಿಡಬಹುದು ಮುಂದಕ್ಕೆ. ಯಾಕೆ? It will allow the rotation. ಅದೇ ವರ್ಟಿಕಲ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ನೀವು ಪುಷ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ತುಂಬಾ ಜಾಸ್ತಿ ಲೋಡ್ ಹಾಕಿದ್ರೆ ಮುರಿದು ಬಿದ್ಬಿಡುತ್ತೆ. ಅದು ನಿಮ್ಗೆ ಬೇರೆ ತರ ಏನೂ ಆಗಲ್ಲ. ಗೊತ್ತಾಯ್ತಾ? ಸೊ ಸಿಂಪಲ್ ಸಪೋರ್ಟ್ ಅಂದ್ರೆ ಓನ್ಲಿ ಒನ್ ರಿಯಾಕ್ಷನ್, ಓನ್ಲಿ ಒನ್ ವರ್ಟಿಕಲ್ ರಿಯಾಕ್ಷನ್, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ simple support. Any doubts in simple support?
No, sir.
Clear? Okay. Now I am coming to next very important thing, that is hinge. What is hinge? How many reactions are expected in hinge? Two. What are those?
Vertical and horizontal.
Vertical and horizontal. See, I will tell you the one technical terms. So whatever the forces, the possible displacements, the vertical and horizontal, that is sigma fx or sigma fy or sigma m. This fx and fy are termed as translations and m is termed as rotation. So in any possible way of displacements are how many translation? Two translations and one rotation. Please keep in your mind, there are two translatory moment. They can be moved in axial directions x and y, and one rotatory type of moment. Now I am coming to hinge. So hinge is having two reactions. So if you consider a joint, possibles are 3. Now because of this vertical reaction, this is 0. Because of this horizontal reaction, this is 0. But theta, that is rotation, or m is possible. Hence it will allow rotation. Hinge support will allow
Rotation.
Support will allow rotations, but controls or will not permit what? Translations. So if you are providing a hinge support, it will allow only one rotation. So generally we are having 3 reactions, that is 2 translation and 1 rotation. In hinge it is having 2 reaction. Because of the 2 reaction, these are 0. It will allow rotations. Hence the external support reaction at hinge support equals to 2, that is Rx and Ry. Sometimes it may referred as Vy and H. Or you can take, if it is A joint, then this is referred as Va HA reactions, right? Or you may refer as Ax and Ay. Those are all are same external support reaction notations. So any doubts in hinge support?
rotation ಅಂದ್ರೆ moment
No,
ಅಲ್ಲ
sir.
sir?
No.
Yes, both are same appa. Illi ನೀವು external ಬಗ್ಗೆ ಮಾತಾಡಬೇಕಾದ್ರೆ theta and m both are same. Theta and m both are rotations. Okay, good aita?
Okay sir.
Okay, next Fixed support. This is very, very important. This is another words is termed as rigid support or rigid support. Rigid support. Okay, here how many external reactions are expected in rigid support? The name itself indicates rigid. Rigid means what? It will not allow translation as well as rotation. It is not allowing
rotation.
translation as well as rotations means you may get how many reactions?
3.
3. If it is A, it is VA, HA, and MA. Here at the joint displacements are 0. That's why it is 0. That's why the support is exhibiting the number of reactions. Depending on what condition, the support reactions can be decided 2, 3 intella, because it depends on 2 translation as well as 1 rotation. If you consider in 2-dimensional structural system, any joint possible displacements are 2 translation and 1 rotation. If the support is hinge, it will allow rotation. It does not allow 2 translation. If the support is fixed, it will not allow any kind of deformations, which means there is 0 translation and 0 rotations. Hence, there are 3 reactions. Any doubts? Hence, there are 3 reactions. Any doubts? Clear? Now, the fourth one. What is the fourth one? Roller. See, it's similar to simple support. It's similar to simple support, which means how many reactions?
Only one.
1. Only one. So this is 0. But it's an axially rigid. It is an axially stiff one. It will allow rotation and it will not allow horizontal movement. If you are providing roller, what is the difference between roller and simple support? What is the difference between roller and simple support? What is the difference? Yes. Anyone please tell me the difference. What is the main difference between roller and simple support?
Roller will be provide horizontal.
Okay.
Vertical, simple support will be vertical.
Vertical. Why we can provide roller horizontally also? Any idea? The answer is right. Why? What is the reason? We can provide. What is the reason? See, this roller support is also called axially rigid, axially stiff. What is meant by axially stiff? Axially stiff means what are the axes? X, Y. So it will not allow the movements in axis, whether it may be X axis or Y axis. It's an axially stiff support. But simple support is not axially stiff, which means simple. You may lift, you may rotate. In simple support, you may, it is a stone. Rest on 2 simple things. If you lift, the stone will rise above. If you rotate, it will rotate. But when you are providing a simple support, it's an axially stiff. You are providing pin. You are providing stiff, axially stiff in both the direction. So which means if you are providing roller in this direction, it will produce reaction in vertical. But it will not allow to horizontal movement also, but it will allow only rotation. If you are providing a roller in this direction, it will resist the axial loads. But at the same time, it will not allow the vertical movement, but it will rotate. Clear? But the thing is, in roller, how many external support reactions? Only one. Only one. Clear? So these are your supports. Any doubts in supports? Any doubts in supports? If you are having any doubts, please ask me. I will clarify your doubts. Any doubts? Okay. We move on to different types of beams. Types of beams. What are different types of beams? Any answers?
Cantilever beam.
Okay.
Simply supported beam.
Simply
Very
supported
good.
beam.
Right?
Double sided overhanging beam.
Okay.
Continuous
Double
beam.
sided overhanging beam.
Very good. Continuous. Double overhang. Yes. Any other answers? Okay. So the classification, see, as a structural engineer point of view, you have to think. Basically, the beams are classified as statically determinate
and statically determinate.
beams and statically indeterminate beams. What is determinate beams? What is determinate beams? What is meant by determinate? What is meant by
The beam
determinate?
whose unknowns can be determined using equilibrium equations.
Very good. The beam which can be analyzed with the help of equations of equilibrium alone. That is called determinate beams. What are the equations of equilibrium?
Sigma fx is equal to
Like
0, sigma
sigma
fy
fx,
is equal to 0, and
sigma fy
sigma
is equal
moment
to
is equal to
moment.
0.
Very good. That is sigma fx equals 0, sigma fy equals 0, and sigma m equals 0. Now you came to my point. These are three possible displacements. ಇಲ್ಲಿ ಏನ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಂತ ಹೇಳ್ತಿದ್ದೀರಲ್ಲ, ಇದೇ ಪಾಸಿಬಲ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ಸ್. ನೀವು ಆಸ್ ಅ ಸಿವಿಲ್ ಇಂಜಿನಿಯರ್ ಆಗಿ ನಿಮ್ಗೆ ಇದು ಗೊತ್ತಿರಬೇಕು. ನಾವು ಯಾವುದೇ ಬಿಲ್ಡಿಂಗ್ ಡಿಸೈನ್ ಮಾಡ್ಲಿ, ಯಾವುದೇ ದೊಡ್ಡ ದೊಡ್ಡ ಟವರ್ಗಳನ್ನ ಡಿಸೈನ್ ಮಾಡ್ಲಿ, ಡ್ಯಾಮ್ ಡಿಸೈನ್ ಮಾಡ್ಲಿ, ಬ್ರಿಡ್ಜ್ ಡಿಸೈನ್ ಮಾಡ್ಲಿ, ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಕಂಡೀಷನ್ ನ ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡಬೇಕು. ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಕಂಡೀಷನ್ ನ ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡೋದು ಏನಂದ್ರೆ, the structure will not allow horizontal displacement, that is sigma fx equal to 0. The structure will not allow vertical displacement, that is your second equilibrium condition, sigma fy equals 0. The structure will not overturn, the structure will not overturn, that is your sigma m equals 0. These are the fundamentals to civil engineering structures. That is called equations of statics or equations of equilibrium. Generally, in two-dimensional structures, the equations of equilibrium are three. What are those? Sigma fx equals 0, sigma fy equals 0, and sigma m equals 0. In three-dimensional structure, how many equations of statics?
6.
Any other answers? This is for two dimension, x, y. Now I want for three dimension, x, y, and z. Yes.
6
Any
equations.
answers? 6. Others? Yes, please guess. As a civil engineers, we must know, right? Okay. See, in three dimensions, what are forces? How many forces? Sigma fx equals 0, sigma fy equals 0, and sigma z equals 0. Similarly, sigma mx equals 0, sigma my equals 0, and sigma mz equals 0. Totally, how many equations of equilibrium? 6. It's very, very important in three-dimensional structures. But for your syllabi, you are having only this part. Hanganbittu sir, idun kelangilva? They may ask in MCQ questions. For 3D, or in other words, space structures. Here, for 2D or planar structures. See, these are all technical terms. You must know this. Clear? Any doubts? See, you must be interactive. ನಾನು ಒಬ್ನೇ ಮಾತಾಡ್ಕೊಂಡು ಹೋಗ್ತಾ ಇದ್ರೆ ನೋ ಯೂಸ್. ನೀವು ಕಲಿಬೇಕಲ್ಲ, ಏನಾದ್ರು ಎಕ್ಸಾಮ್ ನಲ್ಲಿ ಅಟೆಂಪ್ಟ್ ಮಾಡ್ಬೇಕಲ್ವಾ, ಇದೆಲ್ಲ ಗೊತ್ತಿರ್ಬೇಕು. ನಿಮ್ಗೆ ತಪ್ಪಾದ್ರೂ ಪರವಾಗಿಲ್ಲ, ಇಂಟರಾಕ್ಟ್ ಮಾಡ್ರಿ. ಕ್ಲಿಯರ್? ಎನಿ ಡೌಟ್ಸ್?
No, sir. Yes.
Okay, very good. Now,
Yes, sir.
I'm coming to concept. Statically determinate beams means the beam which holds the equation. See, now I will check. See, you told that. What you told that first one? Someone told that simply supported beam anta. Alva?
Yes, sir.
ಸಿ ಯಾವತ್ತು ಸ್ಟ್ರಕ್ಚರ್ಸ್ ನ ಮಕ್ಕಿ ಕಲಿಬೇಡ್ರಿ, ಕಾನ್ಸೆಪ್ಚುಯಲ್ ಆಗಿ ಕಲಿರಿ. ನೀವು ತುಂಬಾ ಜನ ಜೀವ ಎಲ್ಲ ಉಳಿಸ್ಬೇಕು ಫ್ಯೂಚರ್ ಅಲ್ಲಿ. ಓಕೆ, ಕಾನ್ಸೆಪ್ಟ್ಸ್ ನ ನೀಟಾಗಿ ಕಲ್ತ್ಕೊಡಿ. Okay, simply supported beam under the beam rests on two supports. Okay. Okay. Say A and B. A and B. Now the vertical reactions are VA and VB. Now what is the total reactions? How many total external support reactions in simply supported beam? Two. VA
sir.
and VB. VA and VB. That is 2, right? How many available equations of equilibrium?
3.
3. Now this beam comes under which type of beam?
Simply supported.
Simply supported beams comes under which category? Statically determinate or statically indeterminate?
Determinate.
Statically
Why?
determinate.
Determinate. Because we have to
Why?
analyze. We are
Because it is weak.
through using these equilibrium equations.
Yes, because the equilibrium equations available are 3, but the external support reactions are only 2. It can be determinable. If it is more than 3, it cannot be determinable. Hence, it comes under another category. Clear? Now I am coming to another example. Someone told that cantilever beam. What is cantilever beam? One end is fixed, other end is free. Now, how many external support reactions?
3,
Three.
sir.
In case of cantilever, 3. How many available equations of equilibrium?
3.
3. Hence, it comes under?
Determinate.
Yes, determinate. Very, very good. Now I will move on to another example. Someone told that fixed beam. Fixed beam. Now tell me, what is the total reaction in fixed beam?
6.
6. See, ಎಲ್ಲರೂ ಇದೇ ತರ ಫಾಸ್ಟ್ ಕ್ಯಾಚ್ ಮಾಡಬೇಕು. What are the available equations?
3.
3. Hence it is determinate or indeterminate?
Indeterminate.
Determinate.
Indeterminate of order what? Of order what? ಎಷ್ಟಿರ್ಲಿ indeterminate ಆಗಿದೆ?
3.
3. See, ಅದನ್ನು ಕ್ವಶನ್ ನಿಮ್ಗೆ ಕೇಳೋ ಚಾನ್ಸ್ ಇರುತ್ತೆ. Fixed beam is an indeterminate of order. 6, 8, 10, 4 ಹಿಂಗ್ ಕೊಟ್ಬಿಡ್ತಾರೆ. ಅವಾಗ ನೀವೇನ್ ಮಾಡ್ಬೇಕು? ವಾಟ್ ಆರ್ ದ ಎಕ್ಸ್ಟರ್ನಲ್ ಸಪೋರ್ಟ್ ರಿಯಾಕ್ಷನ್ಸ್? ಇಲ್ಲಿ ಇದು ಮೊಮೆಂಟ್, ಹಾಗಂದ್ರೆ 3 ಆಯ್ತಾ? ಇಲ್ಲಿ ಇದು ಮೊಮೆಂಟ್, ಇಲ್ಲೂ 3 ಆಯ್ತು. ಸೊ ದ ಅವೈಲಬಲ್ ರಿಯಾಕ್ಷನ್ಸ್ ಆರ್ 3 + 3 = 6. But what is the equilibrium equations? Equilibrium equations are 3. So now indeterminacy equals R minus total reactions minus 3. So 6 minus 3. So indeterminate of order 3. Order 3. So any doubts? I will give one more example. You know that dropped cantilever beam. ಕೇಳಿದಿರಾ? One end simple support ಕೊಡ್ತಾರೆ, ಇನ್ನೊಂದು end fixed ಇರುತ್ತೆ. Now tell me how many reactions, on which order it is, determinate or indeterminate? Tell me. Try ಮಾಡಿ. Dropped cantilever.
1 degree order. So indeterminate.
1 degree order.
1
Yes,
degree order.
right. How you may say that here 3.
3.
Here 1. What is the total?
1.
4.
Available 3. Therefore 4 minus 3?
1.
1. So it is determinate or indeterminate?
Indeterminate.
Indeterminate.
Indeterminate. So now any doubts in classification of beams? ಏನಾದ್ರು ಡೌಟ್ ಇದೆಯಾ ನಿಮ್ಗೆ? ನೀವು ಮುಂಚೆ ಏನ್ ಮಾಡ್ತಿದ್ರಿ? ಜನರಲಿ ಹೇಳ್ಬಿಡ್ತಾ ಇದ್ರಿ, ಸಿಂಪ್ಲಿ ಸಪೋರ್ಟೆಡ್ ಬೀಮ್, ಕ್ಯಾಂಟಿಲಿವರ್ ಬೀಮ್, ಆ ಬೀಮು ಈ ಬೀಮು ಕಂಟಿನ್ಯೂಸ್ ಏನೇನೋ ಬಿಡ್ತಾ ಇದ್ರಿ. ಹಂಗೆ ಹೇಳಲೇಬಾರ್ದು. ನೀವು ಹೆಂಗ್ ಕಲಿಬೇಕು? ಬೀಮ್ಸ್ ಅಂದ ತಕ್ಷಣ 2 ಟೈಪ್ ಇದೆಯಪ್ಪ. ಒಂದು ಡಿಟರ್ಮಿನೇಟ್ ಅಂತ ಇದೆ, ಒಂದು ಇಂಡಿಟರ್ಮಿನೇಟ್ ಅಂತ ಇದೆ. ಅದನ್ನ ಬೇಸಿಕಲಿ ಈಕ್ವೇಶನ್ಸ್ ಆಫ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಇಂದ ಮಾಡಿದ್ದಾರೆ. ವಾಟ್ ಆರ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಈಕ್ವೇಶನ್ಸ್? ಅದರಲ್ಲಿ ನಮಗೆ ಗೊತ್ತು 2 ಟೈಪ್ ಆಫ್ ಸಿಸ್ಟಮ್ ಇದೆಯಪ್ಪ. ಒಂದು 2 ಡೈಮೆನ್ಷನಲ್ ಸಿಸ್ಟಮ್, ಇನ್ನೊಂದು 3 ಡೈಮೆನ್ಷನಲ್ ಸಿಸ್ಟಮ್. 3 ಡೈಮೆನ್ಷನಲ್ ಸಿಸ್ಟಮ್ ನಮ್ಗೆ ಸಿಲೆಬಸ್ ನಲ್ಲಿ ಇಲ್ಲ, ಬಟ್ 2 ಡೈಮೆನ್ಷನಲ್ ಸಿಸ್ಟಮ್ ನಮ್ ಸಿಲೆಬಸ್ ನಲ್ಲಿ ಇದೆ. ಎಷ್ಟು ಈಕ್ವೇಶನ್ಸ್ ಇದೆ? ಸಿಗ್ಮಾ fx = 0, ಸಿಗ್ಮಾ fy = 0 ಅಂಡ್ ಸಿಗ್ಮಾ m = 0. ಆ 3ನ್ನ ಇಟ್ಕೋಬೇಕು. ಸೊ ಆ 3ರಲ್ಲಿ ಈಗ ನಾನು ಸಿಂಪ್ಲಿ ಸಪೋರ್ಟೆಡ್ ಬೀಮ್ ಅಂತ ಹೇಳ್ತೀನಿ. ಸಿಂಪ್ಲಿ ಸಪೋರ್ಟೆಡ್ ಬೀಮ್ ಅಂದ್ರೆ ಏನು? ದ ಬೀಮ್ ರೆಸ್ಟ್ ಆನ್ 2 ಸಿಂಪಲ್ ಸಪೋರ್ಟ್ಸ್. 2 ಸಿಂಪಲ್ ಸಪೋರ್ಟ್ಸ್ ಅಂತ ನೇಮ್ ಅಲ್ಲೇ ಹೇಳ್ತಾ ಇದೀನಿ. 2 ರಿಯಾಕ್ಷನ್ಸ್. ಬಟ್ ಅವೈಲಬಲ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಈಕ್ವೇಶನ್ಸ್ 3 ಇದೆಯಪ್ಪ. ಸೊ 3 ಇರೋದ್ರಿಂದ ಇಟ್ಸ್ ಡಿಟರ್ಮಿನೇಟ್ ಒನ್. ಸೊ ಇಟ್ಸ್ ಕಮ್ ಅಂಡರ್ ದ ಕ್ಯಾಟಗರಿ ಆಫ್ ಡಿಟರ್ಮಿನೇಟ್ ಬೀಮ್. ಕ್ಯಾಂಟಿಲಿವರ್ ತಗೊಳ್ತೀನಿ. ಕ್ಯಾಂಟಿಲಿವರ್ ತಗೊಂಡ್ರೆ ಫಿಕ್ಸ್ ಒಂದ್ ಎಂಡ್, ಇನ್ನೊಂದ್ ಎಂಡ್ ಫ್ರೀ ಇದೆ. ಫಿಕ್ಸ್ಡ್ ಇರೋದ್ರಿಂದ ಎಷ್ಟು ರಿಯಾಕ್ಷನ್ ಆಯ್ತು? 3 ಅಪ್ಪ. ಸೊ 3 ಇದೆ, ಅವೈಲಬಲ್ ಈಕ್ವೇಶನ್ 3. ಓಕೆ, 3 ಇದೆ, ಡಿಟರ್ಮೈನ್ ಮಾಡ್ಬೋದು. ಹೆನ್ಸ್ ಇಟ್ ಈಸ್ ಆಲ್ಸೋ ಡಿಟರ್ಮಿನೇಟ್ ಬೀಮ್. ಅದೇ ನಾನು 2 ಕಡೆನೂ ಫಿಕ್ಸಿಟಿ ಇದ್ರೆ, ಸೊ ಇದು 3 + 3 6 ಆಗೋಯ್ತು. ಬಟ್ ಅವೈಲಬಲ್ ಈಕ್ವೇಶನ್ ಬರೀ 3. ಆಗಲ್ಲ, ಇಂಡಿಟರ್ಮಿನೇಟ್ ಆಗೋಯ್ತು. ಅದೇ ತರ ಪ್ರಾಪರ್ಡ್ ಕ್ಯಾಂಟಿಲಿವರ್ ಅಂದ್ರೆ 3+1 4 ಆಯ್ತು, ಅವೈಲಬಲ್ ಬರೀ 3, ಸೊ ಇಟ್ ಈಸ್ ಆಲ್ಸೋ ಇಂಡಿಟರ್ಮಿನೇಟ್ ಆಯ್ತು. ಈ ತರ ನಿಮಗೆ ತಲೆನಲ್ಲಿ ಇಮಿಡಿಯೇಟ್ಲಿ ಬರ್ತಾ ಹೋಗ್ಬೇಕು. ಸೊ ಎನಿ ಡೌಟ್ಸ್ ಇನ್ ಟೈಪ್ಸ್ ಆಫ್ ಬೀಮ್ಸ್? Any doubts?
No, sir.
Shall I move on to the next topic? That is next
Sir,
thing.
continuous beam.
Yes. Okay, I will explain those things also. Okay, now tell me, ನೀವೇ ಹೇಳ್ತಾ ಹೋಗಿ. I will classify in table manner, classification of beam. So name of the beam: statically, indeterminate. First one, it's right. ಸರಿ ಅಲ್ವಾ? ಇಲ್ಲಿ ಇನ್ನೊಂದು ಬರಿತೀನಿ. ಇಲ್ಲಿ ಏನ್ ಬರಿಬಹುದು? ಪ್ರಾಪರ್ಡ್ ಕ್ಯಾಂಟಿಲಿವರ್ ತಗೋಬಹುದು. One end is free, one end is fixed, other end provide simply support. Here I will take cantilever. One end is fixed, other end is free. Here I will take fixed. Both end fixed. Okay. Next. Here I will take one more example. If you know overhanging beam, what is meant by overhanging beam? Overhanging beam. What is meant by overhanging beam? Try ಮಾಡಿ. What is meant by overhanging beam?
The beam supported on more than 2 supports.
The beam, see, supports more than one support idre overhang. Now overhanging may be statically determinate or it may be indeterminate. See, ee tara overhang bandre only 2 reactions, statically determinate. I will give you this type of overhang. Now tell me, this is which kind of overhang? Indeterminate, right? Here 3+1 4. Clear? Any doubts? This is also overhang, but it is indeterminate. This is also overhang. This is determinate. Clear? Okay. Next, continuous. Someone told continuous, right? I will take continuous. Continuous. What is meant by continuous beam? What is meant by continuous beam? See, the beam is having more than one span. See, 1 span, 2 span, 3 span. Now, in some time, it may be determinate. See here, how many reactions? 3. In some cases, if I provide fixity, it will become indeterminate.
Yes.
So keep in your mind, don't jump into conclusion that overhanging is always determinate. Allah, depending on given support condition, we must decide it is determinate or it is indeterminate. Clear? The concept is clear?
Yes.
ನಿಮಗೆ MCQ ನಲ್ಲಿ ಕೇಳ್ತಾರೆ ಐಡೆಂಟಿಫೈ ದಿ ಡಿಟರ್ಮಿನೇಟ್ ಬೀಮ್ಸ್ ಅಂತ. ನಿಮ್ಗೆ ಜಂಪ್ ಆಗಿ ಏನೇನೋ ಹೊಡೆದ್ಬಿಡ್ಬೇಡ್ರಿ. ಆಮೇಲೆ ನೀವು ಏನ್ ನೋಡ್ಬೇಕು, ಪ್ರಾಪರ್ಡ್ ಕ್ಯಾಂಟಿಲಿವರ್ ಕೊಟ್ಟವನ, ಫಿಕ್ಸ್ಡ್ ಕೊಟ್ಟವನ, ಸಿಂಪ್ಲಿ ಸಪೋರ್ಟ್ ಕೊಟ್ಟಿದಾನ. ಕೆಲವು ಟೈಮ್ ನಿಮ್ಗೆ ಎಷ್ಟು ನಾಜೂಕಾಗಿ ಕೇಳ್ತಾರೆ ಅಂದ್ರೆ, one end is fixed and 2 spans are simply supported, whether the beam is statically determinate or indeterminate. Yes, no, maybe yes or no, either yes or no, ಈ ತರ ಎಲ್ಲ ಕೇಳೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ ಕ್ವಶನ್ ನಲ್ಲಿ. ಅರ್ಥ ಆಯ್ತನ್ರಿ? ಗೊತ್ತಾಯ್ತಾ? ಸೊ ಕಾನ್ಸೆಪ್ಟ್ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ರಿ. ಎನಿ ಕ್ವಶನ್ ಯು ಮೇಕ್ ಡೈರೆಕ್ಟ್ ಆಗಿ ಕ್ರ್ಯಾಕ್ ಮಾಡ್ಬೋದು. ನಿಮಗೆ ಕಾನ್ಸೆಪ್ಟ್ ಚೆನ್ನಾಗಿ ಗೊತ್ತಿರ್ಬೇಕು ಅಷ್ಟೇ. ಮಕ್ಕಿ ಓದ್ಬೇಡ್ರಿ. ದ ಸ್ಟ್ರಕ್ಚರ್ ಇಸ್ ಎ ಸಬ್ಜೆಕ್ಟ್, ಯು ಮಸ್ಟ್ ನೋ ದಿ ಸಬ್ಜೆಕ್ಟ್. the basics, the fundamentals you must strong. ನೀವೆಲ್ಲಿಗೆ ಇಂಟರ್ವ್ಯೂಗೆ ಹೋದ್ರು ಫಂಡಮೆಂಟಲ್ಸ್ ನಿಮಗೆ ಮೇನ್ ಪ್ಲೇಸ್ ಆಗೋದು. Okay, because if you must know these things, whatever the question they may ask, they may set superior high end question, you definitely ನೀವು attempt ಮಾಡ್ತೀರಾ. Clear? Next ಹೋಗ್ಲಾ ಟಾಪಿಕ್. ಎನಿ ಡೌಟ್ಸ್? ಏನೋ ಡೌಟ್ಸ್ ಇದ್ರೆ ಕೇಳಿ, ಕ್ಲಾರಿಫೈ ಮಾಡ್ತೀನಿ. ಎನಿ ಡೌಟ್ಸ್?
ಸರ್,
ಎಸ್.
ಪ್ರಾಪರ್ ಕ್ಯಾಂಟಿಲಿವರ್ಸ್ ನಲ್ಲಿ ಟೋಟಲ್ 4 ರಿಯಾಕ್ಷನ್ಸ್ ಇದೆ ಅಲ್ಲ ಸರ್?
ಹೌದು.
4 minus 3 1 ಆಗುತ್ತಲ್ಲ.
ಹೌದು,
It is statically indeterminate.
ಆಫ್ ಆರ್ಡರ್ 1. ಈಗ ಏನ್ ಗೊತ್ತನಪ್ಪ, ಇದು ನಿಮ್ಗೆ ಇದನ್ನ ಈಗಲೇ ಹೇಳ್ತೀನಿ ಕೇಳ್ಕೊಳ್ಳಿ, ಯಾಕೆಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ನಾನು ಇದನ್ನೇ ಮತ್ತೆ ಡಿಸ್ಕಷನ್ ಮಾಡ್ತೀನಿ. ಏನಂದ್ರೆ ನಿಮ್ಗೆ 2 ಅನಾಲಿಸಿಸ್ ಇದೆ, ಒಂದು ಸ್ಟ್ಯಾಟಿಕಲಿ ಡಿಟರ್ಮಿನೇಟ್ ಸ್ಟ್ರಕ್ಚರಲ್ ಅನಾಲಿಸಿಸ್, ಇನ್ನೊಂದು ಸ್ಟ್ಯಾಟಿಕಲಿ ಇಂಡಿಟರ್ಮಿನೇಟ್ ಸ್ಟ್ರಕ್ಚರಲ್ ಅನಾಲಿಸಿಸ್. 2 ನಿಮ್ ಸಿಲೆಬಸ್ ನಲ್ಲಿ ಇದೆ, ಆಯ್ತಾ. ಈಗ ಸ್ಟ್ಯಾಟಿಕಲಿ ಡಿಟರ್ಮಿನೇಟ್ ಬೀಮ್ಸ್ ಅಂದ್ರೆ ನಿಮ್ ಫ್ರೆಂಡ್ಸ್ ಆಲ್ರೆಡಿ ಒಬ್ರು ಹೇಳ್ದಂಗೆ, those are the things which can be easily analyzed with the help of sigma fx equals 0, sigma fy equals 0 and sigma m equals 0 ಮಾಡ್ಬಿಡ್ಬೋದು. ಅದರಲ್ಲಿ ಬೆಂಡಿಂಗ್ ಮೊಮೆಂಟ್, ಶಿಯರ್ ಫೋರ್ಸ್ ಅದನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬಿಡ್ಬೋದು. ನಿಂಗೆ ಬೆಂಡಿಂಗ್ ಮೊಮೆಂಟ್, ಶಿಯರ್ ಫೋರ್ಸ್ ನ ಸ್ಟ್ಯಾಟಿಕಲಿ ಡಿಟರ್ಮಿನೇಟ್ ಬೀಮ್ಸ್ ಗೆ ಈಸಿಯಾಗಿ ಮಾಡ್ಬೋದು. ಈಗ ಇಂಡಿಟರ್ಮಿನೇಟ್ ಆಗ್ಬಿಡ್ತು ಅಂದ್ರೆ ನೀನು ಎಕ್ಸ್ಟರ್ನಲ್ ಸಪೋರ್ಟ್ ರಿಯಾಕ್ಷನ್ ನ ಡೈರೆಕ್ಟ್ ಆಗಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡಕ್ ಆಗಲ್ಲ. ನೀನ್ ಇದ್ರಲ್ಲಿ ನೀನು ಈಸಿಯಾಗಿ ಸಪೋರ್ಟ್ ರಿಯಾಕ್ಷನ್ಸ್ ಮಾಡ್ಬೋದು, ಬಟ್ ಪ್ರಾಪರ್ ಕ್ಯಾಂಟಿಲಿವರ್ ಅಲ್ಲಿ ಮಾಡಕ್ ಆಗತ್ತಾ? ನಿನ್ನ ಹತ್ರ ಇರೋದೇ 3 ಇಕ್ವೇಶನ್, ಇಲ್ಲಿ 4 ಬಂದ್ಬಿಡ್ತು. ಅವಾಗ ಏನ್ ಮಾಡ್ತೀವಿ, ವಿ ಆರ್ ಯೂಸಿಂಗ್ ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ಸೂಪರ್ ಪೊಸಿಷನ್. ವಾಟ್ ವಿ ವಿಲ್ ಡೂ, ವಿ ವಿಲ್ ಸ್ಪ್ಲಿಟ್ ದಿಸ್ ಬೀಮ್ ಆಸ್ ಕ್ಯಾಂಟಿಲಿವರ್, ಆಯ್ತಾ. ಇದನ್ನ ರಿಮೂವ್ ಮಾಡ್ತೀವಿ, ಇದನ್ನ ರಿಲೀಸ್ ಮಾಡ್ತೀವಿ. ಅದನ್ನೆಲ್ಲ ನೀನು ಇಂಡಿಟರ್ಮಿನೇಟ್ ಸ್ಟ್ರಕ್ಚರಲ್ ಅನಾಲಿಸಿಸ್, ಅದರಲ್ಲಿ ನಿಮ್ಗೆ ಡಿಫ್ರೆಂಟ್ ಮೆಥಡ್ಸ್ ಗಳು ಬರುತ್ತೆ, ಗೊತ್ತಾಯ್ತಾ. ಈಗ ನಿಮ್ಗೆ ಮೇನ್ ಇಂಟೆನ್ಷನ್ ಇಸ್ ವಿ ಹ್ಯಾವ್ ಟು ಮೇಕ್ ದಿ ಸ್ಟ್ರಕ್ಚರ್ ಆಸ್ ಡಿಟರ್ಮಿನೇಟ್ ಅಂಡ್ ಅನಲೈಸ್ ದಿ ಸ್ಟ್ರಕ್ಚರ್, ಅಷ್ಟೇನೆ. ನಿಮ್ಗೆ ಏನ್ ತಲೆನಲ್ಲಿ ಇರ್ಬೇಕಂದ್ರೆ ಡಿಟರ್ಮಿನೇಟ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ನ ಈಸಿಯಾಗಿ ಅನಲೈಸ್ ಮಾಡಬಹುದು, ಇಂಡಿಟರ್ಮಿನೇಟ್ ಗೆ ಸಮ್ ಎಕ್ಸ್ಟ್ರಾ ಬೌಂಡ್ರಿ ಕಂಡೀಷನ್, ಕಾಂಪ್ಯಾಟಿಬಿಲಿಟಿ ಈಕ್ವೇಶನ್ಸ್ ಅಂತ ಎಲ್ಲ ಬರುತ್ತೆ. ನೀವು ಸ್ಟ್ರೆಂತ್ ಆಫ್ ಮೆಟೀರಿಯಲ್ಸ್ ಇಲ್ಲ ಥಿಯರಿ ಆಫ್ ಎಲಾಸ್ಟಿಸಿಟಿ ಇದನ್ನೆಲ್ಲ ಓದಿದ್ರೆ ನಿಮಗೆ ಗೊತ್ತಿರುತ್ತೆ, ಗೊತ್ತಾಯ್ತಾ. ಅದನ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಬಟ್ ಆಸ್ ಆಫ್ ನೌ ಫಾರ್ ಯುವರ್ ಸಿಲೆಬಸ್ ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂ ನಿಮಗೆ ಏನ್ ಗೊತ್ತಿರ್ಬೇಕಂದ್ರೆ ಇಂಥ ಬೀಮು ಇಂಥ ಆರ್ಡರ್ ನಲ್ಲಿ ಡಿಟರ್ಮಿನೇಟಿವ್ ಇಂಡಿಟರ್ಮಿನೇಟಿವ್ ಅಷ್ಟು ಗೊತ್ತಿದ್ರೆ ಸಾಕು. ಅದನ್ನ ಐಡೆಂಟಿಫೈ ನೀನ್ ಈಗ ಮಾಡಿದ್ಯಲ್ಲ, ಅದು ಸರಿ ಇದೆ. ಪ್ರಾಪರ್ ಕ್ಯಾಂಟಿಲಿವರ್ ಆಫ್ ಇಂಡಿಟರ್ಮಿನೇಟ್ ಆಫ್ ಆರ್ಡರ್ 1, ಈ ತರ ಎಲ್ಲದಕ್ಕೂ ಫಿಕ್ಸ್ಡ್ ಬೀಮು ಆಫ್ ಇಂಡಿಟರ್ಮಿನೇಟ್ ಆಫ್ ಆರ್ಡರ್ 3. ಆತರ ನೀನು ಏನಂದ್ರೆ ಮಕ್ಕಿ ಅಲ್ಲ, ಆ ಕೊಟ್ಟಿರೋ ಫಿಗರ್ ಅನ್ನು ನೋಡಿ ಮಾಡೋದ್ ಗೊತ್ತಾಗ್ಬೇಕು, ಗೊತ್ತಾಯ್ತಾ. ಓಕೆ, ಅದರ್ಸ್ ಎನಿ ಡೌಟ್ಸ್?
No, sir.
ಓಕೆ,
No, sir.
ನೆಕ್ಸ್ಟ್ ಈಗ ನಿಮ್ಗೆ ಬೀಮ್ ಅಂದ್ರೆ ಏನು ಗೊತ್ತಾಯ್ತು, ಸಪೋರ್ಟ್ಸ್ ಅಂದ್ರೆ ಏನು ಅಂತಾನು ಗೊತ್ತಾಯ್ತು. ಯೂಸಿಂಗ್ ದಟ್ ಸಪೋರ್ಟ್ಸ್ ಡಿಟರ್ಮಿನೇಟ್ ಅಂಡ್ ಇಂಡಿಟರ್ಮಿನೇಟ್ ಗೊತ್ತಾಯ್ತು. ಸಿ ಐ ಆಮ್ ಯೂಸಿಂಗ್ ಕನ್ನಡ, ಜಾಸ್ತಿ ಕನ್ನಡ ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀನಿ, ಓಕೆನಾ? ಇಲ್ಲ ಫುಲ್ ನಿಮ್ಗೆ ಇಂಗ್ಲಿಷ್ ನಲ್ಲೇ ಬೇಕು ಅಂದ್ರೆ ಇಂಗ್ಲಿಷ್ ನಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೀನಿ. ಯಾವ್ದಾದ್ರು ನಡೆಯುತ್ತೆ, ಬಟ್ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗ್ಬೇಕು. ಮೈ ಇಂಟೆನ್ಷನ್ ಈಸ್ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗ್ಬೇಕು, ಗೊತ್ತಾಯ್ತಾ. ನಿಮ್ಗೆ ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ಕೇಳಿ. ಇಫ್ ಯಾರು ಕನ್ನಡ ಯಾರು ಇಲ್ಲ ಫುಲ್ ಇಂಗ್ಲಿಷೇ ಬೇಕು ಸರ್ ಅಂದ್ರೆ ಹೇಳಿ, ನಾನು ಹೇಳ್ತೀನಿ, ನೋ ಪ್ರಾಬ್ಲಮ್. ಬಟ್ ಕಾನ್ಸೆಪ್ಟ್ ನ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ರಿ, ಗೊತ್ತಾಯ್ತಾ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ನಿಮ್ಗೆ ಬೀಮ್ ಅಂದ್ರೆ ಏನು ಗೊತ್ತಾಯ್ತು. ಒನ್ಸ್ ಯು ನೋ ದ ಥಿಂಗ್ ಇಸ್ ವಾಟ್ ಇಸ್ ಮೀನ್ ಬೈ ಬೀಮ್, ವಾಟ್ ಇಸ್ ಮೀನ್ ಬೈ ಸಪೋರ್ಟ್, ಅಂಡ್ ವಾಟ್ ಆರ್ ದ ಡಿಫರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಸಪೋರ್ಟ್. ದ ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಈಸ್ types of loading. What are the different types of loading acting on the beam? That is very, very important. Yes, try ಮಾಡಿ. ಯಾವ್ಯಾವ್ದು different types of loading beam ಮೇಲೆ ಆಕ್ಟ್ ಆಗ್ಬೋದು?
UDL.
UDL,
Point load,
ಆಮೇಲೆ ವೇರಿಯಿಂಗ್ ಲೋಡ್, ಆಮೇಲೆ ನೀವು ಹೇಳ್ತಿರೋದೆಲ್ಲ ಸರಿ. ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಕಪಲ್ಸ್ ಆರ್ ಮೊಮೆಂಟ್ಸ್, ದಟ್ ಇಸ್ ಆಲ್ಸೋ ಓಕೆ. ಡಿಫರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಲೋಡ್ಸ್ ನೀವು ಹೇಳಿದ್ರಲ್ಲ, ಅಷ್ಟೇ ಆಕ್ಟ್ ಆಗ್ತಾ ಇರೋದು. ಡಿಫರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಲೋಡ್ಸ್. ಫಸ್ಟ್ ಒನ್, ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ಲೋಡ್. Or point load. See, the beam is like this. Say I'll take simply supported beam. If the load is acting P1 like this or inclined P2 like this, these are called concentrated load. Okay, this one is vertical gravity concentrated load. This is inclined. If inclined loads are given, ನಿಮಗೆ ಗೊತ್ತಾ ರೆಸಲ್ಯೂಷನ್ ಕಾನ್ಸೆಪ್ಟ್ ಗೊತ್ತಲ್ಲ, ಫಸ್ಟ್ ಇಯರ್ ನಲ್ಲೇ ಮಾಡಿದೀರಾ. ಏನ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ? ಇಫ್ ದ ಪಿ ಲೋಡ್ is acting like this, P say at an angle of theta, how to compute horizontal and vertical component?
P cos theta and P sin theta.
P cos theta and P sin theta. Okay, that's right. See, ನಾನು ನಿಮ್ಗೆ ಅದನ್ನು ಬೇಸಿಕ್ ಇಲ್ಲಿ ಹೇಳ್ಬಿಡ್ತೀನಿ, ತಲೆಯಲ್ಲಿ ಇಟ್ಕೊಳ್ಳಿ ಹೆಂಗೆ ಹೌ ಟು ರಿಸಾಲ್ವ್ ಅಂತ. ಯಾಕೆಂದ್ರೆ ನಿಮ್ಗೆ ಜನರಲಿ ಬರುತ್ತೆ, ನಾನು ಹೇಳಿಲ್ಲ ಅಂದ್ರೆ ನಿಮ್ಗೆ ಗೊತ್ತಾಗಲ್ಲ. ಸಿ ದ ಫೋರ್ಸ್ P1 may be acting in less direction or the force P2 may be acting in this direction. Okay, I will take this as alpha, I will take this as beta. Okay, now see, it's the inclined force, P1, P2 are inclined force. The inclination, there is only chances. What are the chances of inclination? It may be with respect to horizontal, or it is with respect to vertical. It is with respect to horizontal, or it is with respect to vertical. Respect to horizontal, or it is with respect to vertical. Okay, inclination now. See, keep in your mind, always inclination angle is cos and remaining one is sine. See, if you resolve into two components, the first thing is direction. The direction with respect to origin, this P1 is acting away or towards?
Away.
Away. So represent both away. Represent both away. Now, what I told, the concept is very simple. Inclination angle is cos, remaining is sine. Here the inclination with respect to x-axis. Hence x-axis is cos. So P1 cos alpha, here P1 sine alpha. Now here I am coming to resolving two ways. So first, the direction is acting away or towards? Towards the origin. This is the origin. It's acting towards. So here represent both are towards. Now here P2. Inclination with respect to vertical or horizontal?
Vertical.
Vertical. Therefore P2 cos beta. Remaining is P2
Sine beta.
Sine beta. Only this much. Ishte resolution. Always the direction. If it is away, the both vertical horizontal are away. If it is acting towards, both horizontal and vertical are towards. And inclination, always inclination angle is cos theta and remaining one is sin theta. Okay, now I will give one or two example. Please try to solve this. Say I will give 10 and 30 degree. What is the horizontal component and vertical component? See, horizontal component is first direction, acting towards. So represent towards. And now tell me, horizontal is how much value?
8.66.
Alala, ನನಗೆ just ಇದನ್ನ ಹೇಳಿ ಸಾಕು, resolve ಮಾಡೋದು ಹೇಳಿ.
10 cos
10 cos 30.
This is 10 cos 30. And this is
10 sin 30.
10 sin 30.
10 sin 30. 10 sin 30. Similarly, I'll give one more. Direction ಮತ್ತೆ ಇದನ್ನ ಹೇಳಿ ಸಾಕು. 20 degree. Give a minute. Get back. Okay, am I audible now? Okay. Yes. This is 2020. Yes, please tell me the values. Horizontal and vertical.
20 cos 20.
Horizontal or vertical? What is the direction? Away? Away. Now tell me, what is...
Vertical.
Yes, 20 cos 20 vertical. And
Vertical.
this is 20 sin 20. ಅಷ್ಟೇ, ನೀವು 4-5 ಈ ತರ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ಬಿಟ್ರೆ ನಿಮ್ಗೆ ಏನು ಸಮಸ್ಯೆ ಆಗಲ್ಲ. Yes, I will give like this. 40. I will give here. Instead of giving angle, I will give slope. Please try. This is 1, 2. Slope. I have given the slope. Slope ಅಂದ್ರೆ ಏನು? ಈ ತರ triangle. 1, 2 ಕೊಟ್ಟಿದ್ದೀನಿ. You take this as theta. Which trigonometric function you can apply? Tan theta. What is tan theta? Opposite by adjacent. Theta equal tan inverse of 1/2. Determine the angle. Now, once you determining the angle, which angle you are getting? This angle. This is theta. Now it will become theta. Afterwards, you resolve. To resolve this, this is like this. This is P cos theta and this is P sin theta. Any doubts? Any doubts? Matte explain madla adana?
Yes, sir.
Yes. Nodi. Is few cases what they will do, they will give like this. They will give slope. They will give like 5, 11 or 2, 3, whatever the value. Whatever the value. Value ಏನಾರ ಆಗಿರಬಹುದು. Value is whatever it may be the value. Okay. ಈ ತರ ಕೊಡ್ತಾರೆ. So on this case, ಇಲ್ಲಿ ನಿಮ್ಗೊಂದು ಟ್ರಯಾಂಗಲ್ ಕಾಣಿಸ್ತಾ ಇದೆಯಾ? ಟ್ರಯಾಂಗಲ್. ಆ ಟ್ರಯಾಂಗಲ್ ನ ತಗೊಳ್ಳಿ. What is vertical distance? 5. What is horizontal distance? 11. You take this as theta. Which trigonometric function is applicable to determine theta?
Tan.
Tan. Why tan? Tan theta equals opposite by adjacent. So tan theta equals opposite by adjacent. So theta equal tan inverse 5 by 11. Whatever value, some value you are getting. Some value you are getting. Okay. Now you just observe this face. It is like this. This is theta now. Once this is theta, this value, the mathematics opposite allied angles, this theta equals to this theta, right? Now, if you take this, this is the same theta value. Now, whatever the theta you have computed here, you are shifting the theta to here, right? Shifting the theta to here. Afterwards, you resolve. Once you are getting theta, this is theta. Now, how to resolve this? You are getting horizontal and vertical component. This is towards, represent towards. The value I have given is 20. Therefore, this is 20 cos theta and this is 20 sin theta. Any doubts? Any doubts? ನೋಡ್ಬೇಕು. ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ, ಇನ್ನೊಂದ್ಸಲಿ ಹೇಳ್ತೀನಿ, ತೊಂದರೆ ಇಲ್ಲ.
No, sir.
Clear?
Yes, sir.
Yes, sir.
Okay. Okay. Next, what are the other possible cases? Okay, ಇಷ್ಟು ಗೊತ್ತಿದ್ರೆ ಸಾಕು ನಿಮ್ಗೆ. Next, now I'm coming to one. First load cases I have explained. Concentrated load. So acting at a point. Acting at a point on the beam. So any doubts in concentrated load? Clear?
No, sir.
Concentrated load concept is clear. Okay. The next concept is, the next is second load is uniformly distributed load. Uniformly distributed load. See, the name itself indicates the load is distributing uniformly over the members. So W per unit and L, or sometimes it may be expressed like this. This is also UDL. Okay, what is meant by uniformly distributed load? Yeno uniformly distributed load andre no. What is meant by uniformly distributed load?
Whose intensity is same throughout the span.
Yes, whose intensity is same throughout the span. See, if you consider a rectangle beam, beam. See, this is just like the whatever the load acting on the beam members are same throughout this span. Dead load of the beam. That is UDL. So whose intensity is same throughout this span means it's just like a rectangle, L into B. Now, the conversion of UDL into point load. How we are converting the UDL into point load? This is the UDL. We are converting that into point load. What is the area of rectangle? What is the area of rectangle?
Length into breadth.
Length into breadth.
Into breadth. Similarly,
Yes.
apply the concept. That is W into L. Here, as per this, W into L. And what is the centroid of rectangle?
Divided by 2.
W by 2.
L by 2.
L by
L
2.
by 2. So when you are converting the UDL into point load, is very, very important concept. That is the area of the thing. The area is just like a rectangle, W into L. and its centroid. The centroid of the rectangle is L by 2. L by 2. So any doubts? Any doubts? For UDL.
No, sir.
For UDL, we are converting UDL into point load using W into L. Acts at L by 2, L by 2. W into L acts at L by 2, L by 2. That is uniformly distributed load. Ishte nim talenalli irbeku. Point load ge ಏನು conversion illa because it's already a load acting at a point. But for the analysis sake in SFD and BMD, we are converting the given UDL distributed loads. In distributed loads, there are two types: uniformly distributed load and uniformly varying load. Any doubts in UDL?
Yes, sir.
Okay. Okay. Now the third one is
Varying load.
varying load. Uniformly varying load. See, these are the loads just like triangular type of loads. This is also W per unit and length. Okay. Now, how to convert this type of load into point load? That's my question. How to convert? What is the area of triangle?
Half into base
Half
into
into
height.
base into length.
Half into base into height. So if you take this as a beam, half into base into height, if you're taking half is half into length into weight, W. So, and here in triangle, there are two things. One is the tip of the triangle. The tip of the triangle is called apex, and whatever the base, this is base. The larger intensity is base. Base. The centroid, when you are taking the CG, when you are taking the CG of triangle, that is the CG of triangle are always acting 2/3 of the length from apex, 2/3 of the length from apex, and 1/3 of the length from base, 1/3 of the length from base, and the area is half into base into height. X bar equals 1/3 of the length from base, and X bar equals 2/3 of the length from apex. From apex. Now tell me, this is the apex. So what is this distance? And what is this distance? And what is the total distance? Is L. Or in other words, when you are converting the uniformly varying load into point load, that is acting WL by 2, 2/3 of the length from apex and 1/3 of the length from base, 2/3 of the length from apex and 1/3 of the length from base. Any doubts? Any doubts? Yes, any doubts?
No, sir.
No,
Clear?
sir.
Are you getting the concept? These are the very important thing, because ನಾನು ನಿಮಗೆ ನೆಕ್ಸ್ಟ್ ಈ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಎಲ್ಲ ಕಾನ್ಸೆಪ್ಟ್ ಹೇಳುವಾಗ ಡೈರೆಕ್ಟ್ ಆಗಿ ಹೋಗ್ತಾ ಇರ್ತೀನಿ. ಇದನ್ನೆಲ್ಲ ಸಾಲ್ವ್ ಮಾಡೋದು ನಿಮ್ಗೆ ಬರಬೇಕು. ದೀಸ್ ಆರ್ ಆಲ್ ಬೇಸಿಕ್ಸ್. Yes, any doubts? Clear? Okay, ನಾನು ಈಗ ನಿಮ್ಗೆ ಇನ್ನೊಂದು ಟೈಪ್ ಆಫ್ ಯೂನಿಫಾರ್ಮ್ಲಿ ವೇರಿಯಿಂಗ್ ಲೋಡ್ ಕೊಡ್ತೇನೆ. ಅದನ್ನ ನೀವು ಹೇಳಬೇಕು. See, instead I'll give like this. This is WL. Now this is apex. ಏನಾಗುತ್ತೆ ಈಗ? The point load will act somewhere here. WL by 2. What is this distance?
2/3.
2/3 of
2 by
length,
2 of L.
1/3 of length.
1/3 of L.
That's all. Any doubts?
No,
Any
sir.
doubts?
No, sir.
ಹೇಳ್ಬೇಕು. ಈ ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ ನಾನು ನಿಮ್ಗೆ ಇದನ್ನೆಲ್ಲ ಹೇಳ್ಬಿಟ್ಟು MCQ ಹೋದಾಗ ಇದು ಹೆಂಗ್ ಬಂತು, ಇದು ಯಾಕಾಯ್ತು ಅಂತ ತರ ನಿಮ್ಗೆ ಡೌಟ್ ಇರಬಾರ್ದು ಮೈಂಡ್ ಅಲ್ಲಿ. ಕ್ಲಿಯರ್? ಓಕೆ. ನೆಕ್ಸ್ಟ್
Yes, sir.
another type. I will take combination. W1, W2, and length. Yes, please convert this particular thing. You first shift this particular. How many loading patterns are there in the given diagram? 2. This is UDL and this is UVL. Okay, how to convert these kind of structures into point loads? How to convert this? First, you consider UDL portion. What is the UDL portion? W1. Next, you consider the UVL portion. So you already considered W1, the total height. See, here to here height is W2. Here to here height is W2. Here to here height is W1. Now you consider W1. Already you considered W1. What is this height now? W2 minus
W1.
This is very, very important. Now, first for UDL, what is the conversion? Rectangle. For rectangle, W1 into L acting at L by 2, L by 2. Acting at L by 2, L by 2. Next, what is the triangle? For triangle, see, always 2/3 is high. Adu confusion ಮಾಡ್ಕೊಂಡ್ಬಿಡಬೇಡಿ. 2/3 ಜಾಸ್ತಿ 1/3 ಗಿಂತ. ಸೊ ಇಲ್ಲೆಲ್ಲೋ ಬರುತ್ತೆ 2/3 ಅಂತ ಲೆಕ್ಕ ಇಟ್ಕೊಳ್ಳಿ. 2/3 ಅಲ್ಲಿ ಆಕ್ಟ್ ಆಗ್ತಾರೆ ಇಲ್ಲಿ. Here 2/3. This is W1 into L, right? At 2/3, you are having one more load. What is that load?
W2
by L.
W1 into L by 2.
W2 minus W1 by 2 into
L.
L. What is the distance? 2/3 of length, and remaining distance is
1/3.
1/3 of length. That's all. Any doubts? Any doubts?
No.
This is the combination. The last thing is couples. It may be clockwise couples or it may be anti-clockwise couples. You are taking those couples while you are computing the reactions directly under moments. Okay. Any doubts?
No, sir.
Any doubt idea?
No, sir.
ಅರ್ಥ ಆಯ್ತಾ?
Yes, sir.
ಏನೇನ್ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ ಇವಾಗ? What are all we discussed? ಏನೇನ್ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ?
Different types
Simply
of
supported
load.
with UDL, UVL combined.
Yes, right. And also, I will give some glance. We discussed regarding what is meant by beams. In beams, what we discussed? Types of
Determine
beams.
supports.
determine.
And next, what we discussed? Types of beams. And afterwards, we discussed types of loads. So, any doubts? ಇದರಲ್ಲಿ ಇಷ್ಟರಲ್ಲಿ ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲಿ ಏನಾದ್ರು ಡೌಟ್ ಇದ್ರೆ ಹೇಳಿ. Any doubts? ಏನು ಇಲ್ಲ ತಾನೆ?
No, sir.
ಓಕೆ, ನಾನು ನಿಮ್ಗೆ ಒಂದು ಸಿಂಪಲ್ ಪ್ರಾಬ್ಲಮ್ ಕೊಡ್ತೀನಿ. ಸಿಂಪಲ್, ತುಂಬಾ ಸಿಂಪಲ್. ಇಲ್ಲೊಂದು ಹಿಂಜ್ ಸಪೋರ್ಟ್ ಕೊಟ್ಟೆ, ಇಲ್ಲೊಂದು ರೋಲರ್ ಕೊಟ್ಟೆ. ಓಕೆ, ಇಲ್ಲೊಂದು UDL ಆಕ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಇಲ್ಲೊಂದು ಪಾಯಿಂಟ್ ಲೋಡ್ ಆಕ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಇಲ್ಲೊಂದು ಕಪಲ್ ಆಕ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ, ಇದೊಂದು 10 kN/m ಕೊಡ್ತೇನೆ, ಇದೊಂದು 20 kN ಕೊಡ್ತೇನೆ, ಇದೊಂದು 5 kN/m ಕಪಲ್ ಕೊಡ್ತೀನಿ. ಎ ಮತ್ತೆ ಬಿ. ಇದು ಒಂದು 4 ಮೀಟರ್ ಕೊಡ್ತೇನೆ, ಇದೊಂದು 2 ಮೀಟರ್ ಕೊಡ್ತೇನೆ, ಇದೊಂದು 2 ಮೀಟರ್ ಕೊಡ್ತೇನೆ, ಇದೊಂದು 2 ಮೀಟರ್ ಕೊಡ್ತೇನೆ. What are the support reactions? Determine the support reactions. Elements of civil engineering. Support reactions ಎಷ್ಟು find out ಮಾಡಿ. Yes, how to determine the support reactions? How to determine? First, how many? ನಾನೇ ನಿಮ್ಗೆ ಇದು ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ. Which type of support ಅಪ್ಪ ಇದು? Hinge. This is which type of support? Roller. Hinges will develop. First, I will write the free body diagram. Hinge will develop how many external support reactions? and roller will develop how many external support reactions? Hinge estapa external support reaction hinge ಹೇಳ್ಬೇಕು ಇಲ್ಲಿ types of support ಬಂತು ಕಾನ್ಸೆಪ್ಟ್ beam ಕೊಟ್ಟಿರೋದು what are those
vertical and horizontal.
that is VA HA vertical reaction and horizontal reaction. Roller how many reaction? One, that is VB. Okay, ಇದು ಮುಗೀತು. ಇಲ್ಲಿ ಏನಾದ್ರು ಡೌಟ್ ಇದೆಯಾ? ಎಕ್ಸ್ಟರ್ನಲ್ ಸಪೋರ್ಟ್ ರಿಯಾಕ್ಷನ್ಸ್ ಬರೆಯೋದಕ್ಕೆ ಏನಾದ್ರು ಡೌಟ್ ಇದೆಯಾ?
No, sir.
ನೋ. ಓಕೆ, ನೌ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟೆಡ್ ಲೋಡ್ ನ ಪಾಯಿಂಟ್ ಲೋಡ್ ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಕ್ಕೆ ಹೇಳ್ತೀನಿ. ಸೊ ಇದು ಡಿಸ್ಟ್ರಿಬ್ಯೂಟೆಡ್ ಲೋಡ್. UDL ನ ಪಾಯಿಂಟ್ ಲೋಡ್ ಕನ್ವರ್ಟ್ ಮಾಡೋದು ಹೆಂಗೆ?
W into L.
W into L 10 into 4
40.
and acting centroid L by 2. L by 2 ಅಂದ್ರೆ 4 by 2 2 meter 2 meter. ಏನಾದ್ರು ಡೌಟ್ ಇದೆಯಾ? Now okay, this is the point load, take as it is 20 kilonewton acting 2 meter and 2 meter, whatever the couple you take the same couple, that is clockwise couple 5 kilonewton meter, and the remaining is also 2 meter. This is B. Okay, this is the free body diagram. This is called free body diagram. What is mean by free body diagram? Free body diagram means the representation of all various forces acting on a structure is called free body diagram. Clear? Now, what are the equations of equilibrium? Yen equations of equilibrium?
Sigma fx is equal to 0.
Sigma fx equals 0.
Sigma fy is equal to
Fy equals 0. Sigma moment at any point. I will take A. A equals 0. First apply sigma fx equals 0. How many horizontal forces are there in the given problem? How many horizontal forces are there?
1.
1. Therefore only, and sign convention is very, very important. Sign convention: vertical upward force positive, vertical downward force negative, right side horizontal force positive, left side horizontal force negative. Now we are talking about this condition, sigma fx. When we are talking about sigma fx, right side forces are positive, left side forces are negative. How many forces? Only one force, that is HA. HA equal to 0. Any doubts? Any doubts?
No, sir.
Next, apply sigma Fy equals 0. If you apply sigma Fy equals 0, what is the sign convention? All upward forces are positive and all downward forces are negative. How many vertical forces? 1, 2, 3, 4. Total 4 forces. Use sign convention also. Use proper sign convention also. So this is plus or minus?
Plus.
Plus VA. Plus VA. Next this is
Minus 40.
40.
minus 40. Next
Minus 20.
20. Next.
Plus VB is equal to 0.
See, don't consider this phi because this is a moment, not a force. I am talking about only force. This is a moment. Okay. So you are getting VA plus VB equals 60.
60.
Take equation
Equals
number
60.
1. Take it as equation number 1. Take it as equation number 1. Okay. Next, what is the remaining equilibrium equation? Sigma
M.
moment at any point. It may be at B or A. For easiness, I will take left hand support. That is sigma MA equals 0. For moment, what is the sign convention? Clockwise moments are positive, anti-clockwise moments are negative. This is the point. This is the point. With respect to this point, HA is 0, VA is 0 because they are acting at the same point. But V40, how it is rotating with respect to A? Clockwise.
Clockwise.
What is the perpendicular distance?
40 into 2.
40. Therefore 40 into
2.
40 into 2. That is clockwise. 40 into 2. Next, this force is moving clockwise. What is the perpendicular distance here to here?
6.
6. Therefore plus 20 into 6. This is also clockwise. Next, this is already a moment. Which kind of moment? This is clockwise or anti-clockwise?
Clockwise.
So plus
Clockwise.
5. This is clockwise. And this VB with respect to how it is rotating?
Anti-clockwise.
Anti-clockwise. So minus VB into what is the perpendicular distance? 2, 4, 6,
10.
8, 10.
10.
Which is equal to 0. Determine VB. This is 80 plus 120 plus 5 equals 10 VB. What is VB? 205, which means 20.5. Check Madi. Substitute to this equation, you are getting VA.
Yes.
60 minus 20.5. How much? 40, 39.
49.5.
49. How much? 49.5 is right? Or 39.5?
39.
39.5. These are the reactions computation. Any doubts? Any doubts? Well, before moving to SFT BMD, you must know how to calculate the external support reactions. Then only that topic is easy. Clear? Any doubts?
No, sir. No, sir.
Okay. Next,
sir.
move on to the next topic. Okay. So I explained regarding beams. I explained regarding supports, hinge, pin, fixed, and also I explained different types of beams. See, this is very, very important. Statically determinate, statically indeterminate. Number of unknown forces can be determined by method of statics. That is sigma fx equals 0, sigma fy equals 0, and sigma m equals 0. Simply supported beam, overhanging beam, cantilever beam. Statically indeterminate. Number of unknown forces cannot be determined using statics alone. That is fixed beam, proper cantilever beam, continuous beam. I have also explained with neat sketches also. See, these are the simply supported beam and cantilever beam. Here, overhanging beam, fixed beam. Proper cantilever beam, continuous beam. See, these are some few examples I have shown in figure. I have already explained. Point load, we explained. Also UDL. UVL and couples. Any doubts? Next, shear force and bending moment diagram. Yes, what is meant by shear force? What is meant by shear force?
The force acting on the surface.
A force acting on
Surface.
surface. Any other answers? What is meant by shear force? ನೀವು ಅಟೆಂಪ್ಟ್ ಮಾಡಬೇಕು, ಏನಾರು ಹೇಳ್ಬೇಕು, ಸರಿನೋ ತಪ್ಪ ಅವ್ನು ಹೇಳ್ದ ನೋಡಿ ಹಂಗೆ ಟ್ರೈ ಮಾಡಿ. ನಿಮ್ ತಲೆಯಲ್ಲಿ ಏನ್ ಬರುತ್ತೆ ಶಿಯರ್ ಫೋರ್ಸ್ ಅಂದ ತಕ್ಷಣ?
The algebraic sum of all the forces acting
Yes,
on the body.
the sum of forces acting all, whether it is right of the section or left of the section. Shear force at a section. Now I'll explain. ನಾನು explain ಮಾಡ್ತೀನಿ ನಿಮಗೆ section ಅಂದ್ರೆ ಏನು ಎಲ್ಲ. Section is equal to sum of transverse loads. Transverse load ಅಂದ್ರೆ vertical loads, either to right side or left side of the section. Okay. And bending moment at section is equal to sum of moments either to the right side or left side. Okay. And shear force diagram andreno, a graphical representation of vertical or transverse forces along the length of the beam is called shear force diagram. And what is meant by bending moment diagram? Bending moment diagram is a graphical representation of various bending moments along the length of the beam. Length of the beam is called bending moment diagram. Any doubts? Any doubt idiyappa?
No,
I will
sir.
explain.
No, sir.
Yes. I will explain the concept. Okay, sign convention irli. Nimge first bending moment to shear force andre enu anta ಹೇಳ್ತೀನಿ, ಆಮೇಲೆ ಅಲ್ಲಿ ಹೋಗೋಣ. Okay. Now we'll come to what is meant by shear force diagram and what is meant by bending moment diagram. Okay, well, before going to shear force diagram, I will explain the sign convention. Then it is very, very easy. And BMD. ಆಯ್ತಾ? ಈಗ ನೋಡಪ್ಪ, one beam ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ. If you consider any one beam like this, beam is a horizontal member. Okay, it's made up of infinite particles. Okay, what I will do, I will take one section. I will cut this beam into two parts. I will take a section. So when you divide this beam, you are getting left part as well as right part. Now, if you take a one, just take a circle like this. Now, I will extend this particular thing. Here also I will extend. See what I'll take here one force P1. I will take somewhere here. I'm having P2. I will take them like somewhere here is P3. I will take somewhere here is P4 and all. Okay. Where P4? Okay. Now tell me, this is for forces. I'm writing for forces sign convention. With respect to this section, how P1 will rotate? How P1 will rotate? Towards
Anti-clockwise.
P1, observe.
Clockwise.
How P2 will rotate?
Anti-clockwise.
Clockwise. How with respect to this section of left side, I'll write left side of the section. What we got left side of the section? All vertical downward forces will develop which kind of moment? Which kind of moment?
Anti-clockwise.
Anti-clockwise. Anti-clockwise means
Minus.
negative. All upward forces will develop which kind of moment?
Clockwise.
Clockwise movement.
So
Positive.
positive. Now you're coming to right side of the section. I'm having two sections, right? Right side of the section. Now, how P4 will rotate? How P4 will rotate with respect to this
Clockwise.
x-axis? It is rotating in clockwise.
Clockwise.
How P3 is rotating?
Anti-clockwise.
Anti-clockwise.
Anti-clockwise. So now tell me, all vertical downward forces will create on right of the section. Which type of moment?
Positive.
Clockwise. So positive. All upward forces will create
Anti-clockwise, negative.
negative. See, be careful when you are taking the sign convention. This is very important point. Very important point. When you are analyzing the beam, if it is a beam, when you are analyzing the beam, you are having two reactions, A and B. If you are starting your shear force analysis left to right, if you are sorting your shear force analysis A to B, that is left to right, what is your sign convention? What is your sign convention? When you are doing A to
Negative to
B,
positive.
all
Negative
upward
to
forces are positive and all downward forces are
Negative.
negative. When you are taking shear force analysis from right to left, that is B to A. What is B to A? What is the sign convention? B to A. All upward forces are negative and all downward forces are
Positive.
positive. Any doubts in shear force computation of forces? I'm not talking about bending moment. I'm talking about only shear force. Any doubts? Okay, I will take one example. Then you are getting the idea. I will take one example. Simply supported beam of AB. Okay, this is A and this is B. Now I will give, say, 10 kilonewton, several forces, 20 kilonewton and 30 kilonewton. Now what is the first step? Reaction. For reaction, say I'll give 2 meters, 2 meters, 2 meters, 2 meters. If you take sigma Fy, so that is 30 plus 30, 60. 60 is the total. If you take moment at B, so you are getting 30 into 6 plus 20 into 4 plus 10 into 2, which is equal to 8 VB. Now you are getting like 180 plus 80 plus 20. So 280, right? 100, 280 by 10. 280 by 10, 2, 4, 6, 8. 280 by 8. ಎಷ್ಟು ಬರುತ್ತಪ್ಪ 280? 8 3s are
35, sir.
35. So 35. So we are getting VB as 35 kilonewton. And what is VA? VA is total load. 60 minus 35. 25. Sarina? 40, 60. Okay. Now, ಈಗ shear force diagram. ಎಷ್ಟು ಸಿಂಪಲ್ ಆಗಿ ಬರಿಬಹುದು ನೋಡಿ. ಈಗ ಸೈನ್ ಕನ್ವೆನ್ಷನ್ ಯಾವ್ದು ತಗೊಳ್ಳೋಣ? ಲೆಫ್ಟ್ ಟು ರೈಟ್ ತಗೊಳ್ಳೋಣ. ಲೆಫ್ಟ್ ಟು ರೈಟ್. ಈಗ ಲೆಫ್ಟ್ ಇಂದ ರೈಟ್ ಹೋದ್ರೆ ಅಪ್ವರ್ಡ್ ಏನು? ಏನು ಅಪ್ವರ್ಡ್ ಫೋರ್ಸ್?
Positive.
Positive. So plus 25. Positive ಆಯ್ತು. Plus 25. Plus 25. This is positive. Next, ಇದನ್ನ ಲೀನಿಯರ್ಲಿ ಹಿಂಗ್ ಬರ್ತೀನಿ. ಇಲ್ಲಿ 10 ಇದೆ. 10 ಆಕ್ಟಿಂಗ್ ಡೌನ್ವರ್ಡ್ ಅಲ್ವಾ? ಡೌನ್ವರ್ಡ್ ಅಂದ್ರೆ ಏನು? Minus 25 minus 10.
15.
15. This is 15. Next, once again, I'll go here. What is this? Is it acting downward or upward?
Downward.
Downward means minus here 15. 15 minus 20?
Minus 5.
Minus 5. It will go to here. This is minus 5. This is minus 5. Here, 5. Now, once again, I'll go to here. Minus 5, minus 30. How much?
Minus 35.
Minus 35. I'll go to here. The reaction is upward. Plus 35. It is 0. This is SFD. Very simple. This is negative. This is positive. Now, what I did, I came left to right. Now, I will came right to left. For the same sign convention, I will come. This what I did. This is right to left. Okay. Now, I will come from left. Okay. At left. Upward is what?
Positive. Sorry, negative.
Negative. Therefore, minus. This is upward force, right? So minus 35. I had to come here. Here, downward is positive. See? So minus 35 plus 30. How much? Minus 35 plus 30. History?
5.
5. Minus 5. This is 35. Minus 5 alvandri. 35 minus 35 plus 30.
Minus 5.
Minus 5. Minus 5. Minus 5. Minus 5 plus 20. How much?
15.
15 plus 15. Plus 15 plus 10. How much?
25.
Plus 25. Plus 25 minus 25. How much?
0.
0. See, any variation in diagram? Any variation idya?
No,
Any
sir.
variation? Any variation? We are getting
No.
same, right? 15, 25. Here also 25. Here also 15, 25, 25. So whether you may use right to left or left to right, this sign convention is very, very important. So ಯಾವ್ದನ್ನ ತಲೆಯಲ್ಲಿ ಇಟ್ಕೋತೀರಾ? ಯಾವ್ದು ಫಾಲೋ ಮಾಡ್ತೀರಾ? ಲೆಫ್ಟ್ ಟು ರೈಟ್ ಮಾಡ್ತೀರಾ? ರೈಟ್ ಟು ಲೆಫ್ಟ್ ಮಾಡ್ತೀರಾ?
Left to right.
Left to right.
ಇಟ್ಸ್ ವೆರಿ ಈಸಿ. ರೈಟ್ ಟು ಲೆಫ್ಟ್ ಬರ್ತೀರಾ ಅಂದ್ರೆ ಮೈನಸ್ ಅಲ್ಲಿ ಏನೇನೋ ಆಗ್ಬಿಡುತ್ತೆ ಸರ್ ಅಲ್ವಾ? ಹಂಗಲ್ಲ. ಕಾನ್ಸೆಪ್ಟ್ ನಿಮ್ಗೆ ಯಾವ್ದಲ್ಲಿ ಈಸಿ ಅನ್ಸುತ್ತೋ ಆ ತರ ಮಾಡ್ಬೋದು. ಎರಡೂ ತರನು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ಬೇಕು. MCQ ಗಳಲ್ಲಿ ನೀವು MCQ ಗಳನ್ನ ಸೆಟ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಎರಡೂ ಗೊತ್ತಿದ್ರೆ ಈಸಿ, ನಿಮ್ ಟೈಮ್ ವೇಸ್ಟ್ ಆಗಲ್ಲ. ಅದಕ್ಕೆ ನಿಮ್ಗೆ ಎರಡನ್ನೂ ಹೇಳಿದ್ದು. ಇಲ್ಲ ಒಂದನ್ನ ಹೇಳ್ಬಿಟ್ಟು ನಾನು ಬಿಟ್ಬಿಡ್ಬೋದಿತ್ತು. ಎನಿ ಡೌಟ್ಸ್ ಇನ್ ಶಿಯರ್ ಫೋರ್ಸ್ ಡಯಾಗ್ರಾಮ್? ಎನಿ ಡೌಟ್ಸ್ ಟು ಪ್ಲಾಟ್ ಶಿಯರ್ ಫೋರ್ಸ್ ಡಯಾಗ್ರಾಮ್? ಅದನ್ನ ಹೇಳ್ಕೊಡ್ತೀನಿ ಹೆಂಗ್ ಪ್ಲಾಟ್ ಮಾಡೋದು ಅಂತ. ಅದನ್ನ ಇನ್ನು ಡೀಟೇಲ್ ಆಗಿ ಹೇಳ್ಕೊಡ್ತೀನಿ. ತುಂಬಾ ಈಸಿ ಇದೆ ಅದು. ಓಕೆ, ಈಗ ನಿಮ್ ಕಾನ್ಸೆಪ್ಟ್ ಅರ್ಥ ಆಯ್ತಾ ಸೈನ್ ಕನ್ವೆನ್ಷನ್ದು? ಡೌಟ್ ಇದೆಯಾ?
No,
No,
sir.
sir.
ಓಕೆ, ಕ್ಲಿಯರ್? ದ ಕಾನ್ಸೆಪ್ಟ್ ಇಸ್ ಕ್ಲಿಯರ್? ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಬೆಂಡಿಂಗ್ ಮೊಮೆಂಟ್ ಒಂದು ಹೇಳ್ಬಿಡ್ತೀನಿ. ಅದನ್ನು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. ನಿಮ್ಗೆ ಇದೆಲ್ಲ ನೀವು ತಲೆಯಲ್ಲಿ ಹಂಗ ಬಂದ್ಬಿಡ್ಬೇಕು. ನಿಮ್ ಪ್ರಾಬ್ಲಮ್ ನಾನು MCQ ಎಲ್ಲ ಕೊಡ್ತಾ ಇದ್ರೆ ನಿಮ್ಗೆ ಆನ್ಸರ್ಗಳು ಅಲ್ಲಿ ಗೊತ್ತಾಗ್ತಾ ಇರ್ಬೇಕು. ನೆಕ್ಸ್ಟ್ ಬೆಂಡಿಂಗ್ ಮೊಮೆಂಟ್ ಡಯಾಗ್ರಾಮ್. ನಿಮ್ಗೆ ಏನಾಗುತ್ತೆ, ಇದು ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ ಇನ್ಫ್ಲೂಯೆನ್ಸ್ ಲೈನ್ ತುಂಬಾ ಕಷ್ಟ ಆಗ್ಬಿಡುತ್ತೆ. bending moment diagram. See, bending moment. See, what are the different types of bending moment? Hogging, sagging. ಕೇಳಿದಿರಾ?
Yes, sir.
Yes, sir.
ಏನು ಸ್ಯಾಗಿಂಗ್ ಅಂದ್ರೇನು, ಹಾಗಿಂಗ್ ಅಂದ್ರೇನು?
ಸಾಗಿಂಗ್ ಅನ್ನೋದು ಜೋತಾಡೋದು ಸರ್.
ಜೋತಾಡೋದು. ಹಾಗಿಂಗ್ ಅಂದ್ರೆ ನೇತಾಡೋದು. ಓಕೆ. ಸೊ ಹಾಗಿಂಗ್ ಅಂದ್ರೆ ಪಾಸಿಟಿವ್ ಮೂಮೆಂಟ್, ಸ್ಯಾಗಿಂಗ್ ಅಂದ್ರೆ ಪಾಸಿಟಿವ್ ಮೂಮೆಂಟ್, ಹಾಗಿಂಗ್ ಅಂದ್ರೆ ನೆಗೆಟಿವ್ ಮೂಮೆಂಟ್. ಆ ತರ ಹೇಳ್ಬೇಕು. ಜೋತಾಡೋದು, ನೇತಾಡೋದು ಅದು ಓಕೆ, ತೊಂದರೆ ಇಲ್ಲ. ನೀನ್ ಪ್ರಾಕ್ಟಿಕಲ್ ಪರ್ಪಸ್ಗೆ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ಓಕೆ ಓಕೆ. ಸೊ ಸ್ಯಾಗಿಂಗ್, ಹಾಗಿಂಗ್. ಸ್ಯಾಗಿಂಗ್ ಅಂದ್ರೆ ಪಾಸಿಟಿವ್ ಮೂಮೆಂಟ್, ಹಾಗಿಂಗ್ ಅಂದ್ರೆ ನೆಗೆಟಿವ್ ಮೂಮೆಂಟ್. ಸಿ ಅದು ಹೆಂಗ್ ಡೆವಲಪ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ, ಸಿ ದ ಬೀಮ್, if it is a beam, I am applying force on a beam like this. What happens? How it bends? If the beam bends like this, which kind of moment is responsible? Like this, you are applying the moment. If the beam is bends like this, here like this, ಇದನ್ನ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. ಇದು ಬೇಡ ನಿಮ್ಗೆ, ಇದು ಕನ್ಫ್ಯೂಷನ್ ಆಗುತ್ತೆ. ಇದು ಬೇಡ, ಇವೆರಡು ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. ಓಕೆ, ಇವೆರಡು. ಸೊ ಹಿಯರ್ ಯು ಆರ್ ಅಪ್ಲೈಯಿಂಗ್ ಎಂ, ಹಿಯರ್ ಎಂ, ಹಿಯರ್ ಆಲ್ಸೋ ಎಂ, ಹಿಯರ್ ಆಲ್ಸೋ ಎಂ. ಇಲ್ಲಿ ನಿಮ್ಗೆ ಏನ್ ಮಾಡ್ತೀನಿ, ಇದು ಲೆಫ್ಟ್ ಕೊಡ್ತೀನಿ, ಇದು ರೈಟ್. ಇದರಲ್ಲಿ ಇದು ಲೆಫ್ಟ್, ಇದು ರೈಟ್. ಇವಾಗ ಲೆಫ್ಟ್ ಸೈಡ್ ಇಂದ ಫಸ್ಟ್ ಬರಿತೀನಿ. ಲೆಫ್ಟ್ ಸೈಡ್ ಇದು ಕ್ಲಾಕ್ ವೈಸ್, ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್?
ಆಂಟಿ ಕ್ಲಾಕ್
Clockwise, sir.
ಕರೆಕ್ಟ್ ಹೇಳ್ಬೇಕು. ಕ್ಲಾಕ್ ವೈಸ್, ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್?
ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್.
Anti-clockwise.
ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್. ಸೊ ಲೆಫ್ಟ್ ಸೈಡ್ ಬರಿತಾ ಇದ್ದೀನಿ. ಲೆಫ್ಟ್ ಸೈಡ್, or you take L to left side to right side. Here right side to left side. So anti-clockwise is negative. Here same left. ಇದು ಒಂದಾಯ್ತು. ಇಲ್ಲಿ ಲೆಫ್ಟ್ ಬನ್ನಿ. ಇಲ್ಲಿ ಏನಿದು ಲೆಫ್ಟ್ ಸೈಡ್?
Clockwise.
Clockwise is positive. ಅದೇ ತರ ರೈಟ್ ಸೈಡ್ ಬನ್ನಿ. ಇಲ್ಲಿ ರೈಟ್ ಸೈಡ್ ಏನು? ಇದು ಲೆಫ್ಟ್, ಇದು ರೈಟ್ ಅಲ್ವೇನ್ರಿ? ಇಲ್ಲಿ ರೈಟ್ ಏನು?
Clockwise.
Clockwise, that is positive. ಇಲ್ಲಿ ರೈಟ್ ಸೈಡ್ ಏನು?
Anti-clockwise.
Is negative. This is the sign convention. If you are considering a section, left to right, left to right, left to right, clockwise positive, anti-clockwise negative. Right to left, clockwise. What is clockwise? Right to left. Anti-clockwise is, this is right to left. Here clockwise is positive, anti-clockwise is negative. Clear? Concept is clear?
Yes, sir.
ಅಂದ್ರೆ ಫೋರ್ಸ್ ಏನಾಗುತ್ತೆ ಲೆಫ್ಟ್ ಟು ರೈಟ್ ಅಲ್ಲಿ? ಅಪ್ವರ್ಡ್ ಪಾಸಿಟಿವ್, ಡೌನ್ವರ್ಡ್ ನೆಗೆಟಿವ್. ಅಪ್ವರ್ಡ್ ನೆಗೆಟಿವ್, ಡೌನ್ವರ್ಡ್ ಪಾಸಿಟಿವ್. ಇವಾಗ ನೀವು ನೋಡಿ, ನೀವು ಯಾವ್ದು ಬೇಕಾದ್ರೂ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. ಯಾವ್ದು ನೆನ್ಪಿಟ್ಕೊಳ್ಳೋದು ಈಸಿ?
Left to right.
ಲೆಫ್ಟ್ ಟು ರೈಟ್ ಇಸ್ ವೆರಿ ವೆರಿ ಈಸಿ. ಅದಕ್ಕೆ ವೈಸ್ ವರ್ಸ, ರೈಟ್ ಟು ಲೆಫ್ಟ್. ಕ್ಲಿಯರ್? ಎನಿ ಡೌಟ್ಸ್ ಇನ್ ಸೈನ್ ಕನ್ವೆನ್ಷನ್?
No, sir.
Here tell me which one is sagging and which one is hogging. ಅದು ಇಂಪಾರ್ಟೆಂಟ್. ಇವೆರಡರಲ್ಲಿ ಯಾವ್ದು ಸ್ಯಾಗಿಂಗು, ಯಾವ್ದು ಹಾಗಿಂಗು?
ಹೆಂಗಪ್ಪ ಇಲ್ಲಿ ಹೇಳೋದು?
Second one is sagging.
See,
left
if
to
the
right is hogging.
baseline ಇಂದ ಮೇಲಿದ್ರೆ ಪಾಸಿಟಿವ್, ಕೆಳಗಿದ್ರೆ ನೆಗೆಟಿವ್. ಇವಾಗ ಒಂದು ಬೇಸ್ ಲೈನ್ ತರ ಅಸ್ಯೂಮ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಇದ್ರಲ್ಲಿ ಯಾವ್ದು ಮೇಲ್ ಬರುತ್ತೆ, ಯಾವ್ದು ಕೆಳಗ್ ಬರುತ್ತೆ ಹೇಳಿ. ಯಾವ್ದು ಸಾಗಿಂಗು, ಯಾವ್ದು ಹಾಗಿಂಗು?
Left one's hogging, right one hogging.
Left one, if it is a baseline, it will bend below the baseline. Therefore, this is, and if it is a baseline, it will bend above the baseline. Okay, so this is, first one is, ಯಾವ್ದು ಕರೆಕ್ಟ್ ಆಗಿ ಹೇಳ್ಬೇಕು? Which one is hogging and which one is sagging?
First one is hogging.
Yes, second one is sagging. It is bent above the baseline. First one is bent below the baseline. Clear? Any doubts? ಅದೇನ್ ಸುಮ್ಮನೆ ಹೇಳಿದ್ದು, ಬಟ್ ನಿಮ್ ಸೈನ್ ಕನ್ವೆನ್ಷನ್ ತಲೆದಿರ್ಬೇಕು. ಎನಿ ಡೌಟ್ಸ್ ಇನ್ ಸೈನ್ ಕನ್ವೆನ್ಷನ್? ಓಕೆ ಪಾ, ಥ್ಯಾಂಕ್ ಯು. Okay, you are having lunch break now. Thank you. We will meet on Monday. Any doubts to hear? Any doubts?
No, sir.
No, sir.
Clear?
No, sir.
Today we discussed so many things. All are very, very important topics. Okay. Thank you, Pa. Thank you all. You can leave the meeting. Okay, ma. Thank you.